Go ahead and start it up then.
Anybody else? There you go. So it's all in ISO, and you really should use VMware to get it set up.
We are going to take a break about 30 minutes into the class to stop and build the lab.
It was built with a program. Here, if you guys want to see that. If you guys build it in.
Oh, it's not recording it. It's not getting any. There you go.
That's fine. If it doesn't record, it doesn't record. This is the first ever of this program. Oh yeah, sorry, man. All right, no worries. Yeah. So we're actually going to go through and pull that up.
Yeah, we're currently on and just recording slides.
All right.
Hold on just a second.
So is this a live ISO? We just boot it?
Is the lab content hosted online anymore?
What was that?
Is the lab content hosted online anymore?
The lab content, it was finally completed just like 3-4 days ago. It will be online at evilsecurity.agency, but the site is actually offline because we're changing out our infrastructure right now. So it will be, but unfortunately not. So I will work with Adrian when he gets the video posted that we can maybe put in a caption for the video. Or maybe on the YouTube link, we'll be able to put where you can download the ISO files. So sorry for starting class late. I had to have them go get me a lamp because we're actually going to do a replay attack against a power play. And take over a lamp.
If you want the lights brighter, I didn't them because you can't see it.
It's all good. Okay, so I have to hang on to this one because somebody is supposed to be coming down. But I have, for anyone who doesn't have one, I have one spare Hack RF one.
How much are they?
Huh?
How much are they?
These things are like $200, $300.
Is it just used for the class?
Yeah, used for the class. No, I didn't.
You're not hitting them out? Come on, man!
It's from my kit for work. No, I took all of ours from my kit. But yeah, does anyone need one for the class? Yeah.
The vertical one is
Yeah. Okay. Fine. Yeah. If all you have is an RTL SDR, you're still easily being able to do all this stuff in the class. The only thing you can't do is actually sorry. So the only thing that you can't do is transmit. So any of the projects where we get to where you're actually going to transmit, you can't transmit without one. Alrighty. Okay. All right. So thanks for coming to the class. You got 4 hours of listening to my nice baritone voice. Let's see. Requirements. If you've got a laptop, you're in luck. If you've got VMware, you're doing even better. If you've got VirtualBox, you're going to have some USB issues, I am sure, if you're using the Hack RF one. If you can do this in VMware instead, it's a lot nicer. You can do some of this stuff with the Hack with the yardstick if you brought that instead. But to do any of the labs, you got to at least have the RTL SDR or the Hack RF. So that's where that's going to start. We're going to go through. We're going to go through start to finish, but I do want to just manage those expectations. this is where you might have come to the class thinking, oh, gee, we're just going to go and code stuff and learn how to play in RF. But in truth, reality never is like that. We're going to pretty much get to about here. This is if you've not ever played with RF before, if you've just got an RTL SDR, a little $20 dongle, you can go and have a lot of fun. You can intercept like pager messages and other traffic and start playing with ones and zeros and decrypting things. But if you get into any of the transmitting stuff or getting into other protocols like Zigbee and Bluetooth and all that, the gear gets very expensive very fast. And there's actually a heck of a learning curve. So, that's me. Not that anyone really cares. Most of you guys are going to remember who that I did. Oh, thank you. That was the selfie. Believe it or not, that was a selfie. Yep. All right. So I used to be in the military. I was in the Navy for longer than I care to admit. But I worked in cryptography, mostly with wireless signals. So that's where the basis of this stuff came from. But otherwise, in my normal daily job, I'm a senior security consultant for Rapid7. And we'll move on. I am going to put you to sleep in the first little bit. So if you have anything that you need to do, phone calls you need to get, someone you need to call, bring them on down to class, order a pizza, I don't care, whatever it is. I'm going to teach you how to sleep with your eyes open for a history exam, but I'm a nerd. The rest of this stuff, we're going to start really getting into it. In between all this stuff is there's actually labs. And then we're going to start going into a little bit more advanced topics, rolling codes, GNU Radio Companion. The GNU Radio Companion, I want to preface this as, it's here and we're going to talk about it. That's it. There is not going to be a lab on this. Mike Osmond from who actually made the Hack RF, Hack 5, GNU Radio Companion has their own. If you go out to the wiki, which is the homepage that's in the ISO I gave you, if you go out there, like there's so much stuff on GNU Radio Companion. There's no way we could even begin to cover it. And I've got to support all kinds of devices, so we're going to skip that. We're going to talk about it and skip it, but we're going to play with a lot of other fun stuff. Alrighty. Hi there, welcome. Need something?
Yeah.
Alright. The history of electromagnetism. Hans Ørsted, 1819, current carrying through a wire could move a magnetized needle. So the whole point of this is a wire carrying a current could move a magnetized needle. If you've ever played with a compass and you've ever put like a magnet in front of it or around it, it can pull that needle off one side or the other. Well, that's a magnet, but that's freestanding magnet, right? So in 1819, Hans Ørsted found that if a current going through a wire could also do the same thing. So it had some small principles of an electromagnet. In 1825, Sturgeon demonstrated the first ever electromagnet. Pardon me, I'm also getting over pneumonia. In 1830, Joseph Henry invented the first rudimentary telegraph that transmitted current over a mile, and then hit an electromagnet. In 1865, James Maxwell published the theory of electromagnetism. I want you to keep that in mind. There is a difference between electromagnet and electromagnetism. We're going to talk about that in just a few minutes. In 1886, Heinrich Hertz actually proved Maxwell's theory. He is considered the granddaddy, the father, the almighty god of RF. That's why we praise his name when we talk about radio signals. So everything in the RF spectrum that we're going to talk about is usually, you might hear hertz, kilohertz, megahertz. Even if it's just 1 hertz, it's always hertz because it is his name. So, and then in 1901, Marconi actually sent a signal all the way across, sent Morse code all the way across the Atlantic. If you think about that, this is 1901, right? So in 1901, we've got just over 100 years. In just over 100 years, we've gone from being able to send dots and dips from across the ocean to cellular communications and satellite. Maybe in the industrial spaces, in the heavy engineering, the guys that actually do this stuff for radio broadcasting, for video, things like that, they play with some really cool stuff, and there's collegiate level classes on all this. But as far as amateurs and hobbyists, this is really
that's the
like
same
a
thing.
prime time to be getting into any of this stuff. So, yeah. Let's see, that one's empty. There's some space. A few different places there. Alright. Okay. Electromagnet versus electromagnetism. An electromagnet is the actual physical device itself. So electromagnet involves putting a charge on a coil, or a charge on a wire that's been coiled around a piece of soft metal, and it creates a magnet. Maybe in school, in grade school, or maybe like a freshman year of high school, you may have put a battery on a piece of coil wire and like picked up a paper clip or some staples, something really super light. That is actually building an electromagnet. The theory of electromagnetism is the interaction of electric and magnetic fields when this happens. So as we apply a current through this wire, we end up with two different fields that oscillate 90 degrees from each other. We end up with an electric field, which is represented here in blue, and we end up with backwards here, but it's an electric field represented in red here, and a magnetic field represented in blue there. So you actually have two fields that oscillate together off of this. And that's where the theory of electromagnetism comes in, and that's what we're really playing with here. We're playing with those fields. So when we make a wave, this is a very rudimentary, very old school telegraph with a wire connected to it. Basically what would happen here, battery comes in, supplies the power, hits the capacitor charges, and it leaps across. When it leaps across the gap, the spark gap here, it actually resonates all the way through the antenna. And as it resonates through the antenna, it sends out both sets of waves, both an electric wave and a magnetic wave. And it just keeps going in cycles and cycles and cycles. Let's see. Okay, now, electromagnetic waves are signals that are made up of oscillating electric and magnetic waves. Both fields radiate simultaneously, perpendicular to each other. Okay, so if we have, let's say, parallel, if we have parallel magnetic wave, we actually have a horizontal or a perpendicular. Stumbling over my words. So if we have an electric wave that goes parallel to the ground, we've got a perpendicular magnetic wave. But we can use these properties, and we can actually control them in any different way that we want to. So we can change how we polarize from those antennas. We can actually change how we want to maneuver those magnetic waves and get them to do, into different patterns what we want. So we have a horizontal polarized, vertical polarized, dual polarized, sending two signals at the same time. Cross polarized, just tilt it off by 45-degree angle. Or, as it gets a little further in, you have circular polarized, which means not only do we have two-dimensional structure, now it's now a three-dimensional structure, we have a four-dimensional structure because it is now spinning in time as it goes. Anybody asleep yet? I'm amazed. So I actually did these first slides up to this point with my team at a hackathon, and I spoke to them for the first hour and a half straight. Not on these first 5 slides, but just an hour and a half straight. By the time I got to this slide, I had 3 people asleep already. So I appreciate y'all staying awake. Really, I do. All right, so. Now we've talked about the overarching, what we can do and control the wave. Let's talk about the wave itself. Waves travel at the speed of light, or 299,000 something or other, whatever it says up there on the screen. I would like to preface this with meters per second. So in meters per second, we always have to take into account when we're measuring out radio waves and their length, it's always in meters, so you have to make sure you convert for it. When you're if you just want to make a quick calculation for it, if you ever need to use the speed of light, so when we calculate things like wavelength, we can always just use 3 times 10 to the 8th, or 300 million. Pardon me. So frequency is basically how fast we're going to get these oscillations to go. Taking a look down here on the right-hand side. Yes, to the right. We actually have a wave that crests in a sine pattern. As it hits peak, goes to a valley, and then comes back up. This one whole section is considered one wavelength. The number of wavelengths over a given time, makes our frequency. So frequency is the oscillations, or cycles per second, measured in hertz. We're going to expand on that in just a minute. But wavelength, or how do we actually measure that actual wavelength? Wavelength is measured in, this is not Half-Life the game, this is actually the lambda symbol. It's the speed of light divided by the frequency, or the number of oscillations. Amplitude is the actual amount of power that's being applied at any given time. And, let's see. One unique thing about this is, remember back in the previous slide, we actually had where we could rotate this. So not only do we have signals that can rotate, but also measured in 360 degrees. Going through grade school, you probably sat and had to do all this math with sine and log and all the trigonometry. This is all where it applies. If you never wanted to ever do it again, you don't really have to anymore. We've got computer programs that do it all, but if you wanted to do it by hand for fun because you're a number file or a sadist, you can actually calculate it out. But, so it's measured in 360 degrees. When we get into the different types of modulation, or the ways that we can manipulate these particular wavelengths, change their frequency, change their data patterns, call out data points, rather, you can actually you actually have to keep in mind what they're shifting at. So when we get to those levels of shift, we're going to start talking about the degrees of the radio wave. All right. So when we talked about wavelength, I know this is a very busy slide, but there's a very good reason for all this. When we talked about wavelength, the frequency at which it travels at, okay? The wavelength, if we have 10 to the third, those wavelengths are big enough to cause monumental vibrations. We can actually measure earthquakes and tsunamis by the amount of force from a radio wave. But the radio wave itself are massive. And we have 10 to the third, which is going so slow. It may take a very considerable amount of time to get from point A to point B. But the size of that wavelength, if we could uncover it and see it with the naked eye, is as tall as a skyscraper in New York City. As we start to speed up the oscillation, so increase the frequency, we actually start decreasing the size of the frequency. So have you ever maybe played with a jump rope or a long piece of rope, and you sit there and you would bounce it and it would make the squiggles or go side to side or make loops in it and things like that? Well, what happens when you hit it? You have to go really slow to get really nice, big, long loops. But the faster you can get your hand going, you can get a lot more of those loops in the sine wave through the rope. But it would obviously make it smaller. It's the same principle that we've got going here. So as we go smaller and smaller and smaller, it gets infinitely smaller. Gamma rays, 10 to the negative 12. That's the size of an atom, or a nuclei of inside an atom. I mean, that's incredibly small. When we, as human beings, try to observe this small area right here, 10 to the, I think it's 13 through, or 10 to the 12.5 to 15.5 or something like that, it actually, you get visible light. So if you've ever played with like a Philips Hue light bulb and you're actually playing with the LEDs inside of it to change the color and change the light pattern, you're actually manipulating the light wave that's coming through. And it's, you're changing the oscillation of the frequency. So this is where we get our actual light from. So we can actually measure it and see it here. But as we go faster, it just drops off so fast we can't see it anymore. Hence where we get to like X-ray for taking pictures through the body by 10 to the 18. Okay, let's see. Okay. All right. So Anybody still have? Did anybody not get the? Did anybody not get the USB?
What's on it?
There is an ISO on here, and that's all it is. There shouldn't be anything else. It's just an ISO. I burned these this morning. The ISO needs to be booted into VMware, preferably. You can put it into VirtualBox. There should be instructions on all the tables on how to actually set up this lab. So the first part wasn't so boring, right? One of the biggest feedbacks I actually got from my team was knock it off. I mean, because I have over 500 classroom hours of training in radio waves from the military. Trying to condense that down to 4 hours, I felt like I was trying to explain way too much, and they said, yeah, stop it. So I'm glad no one fell asleep. Okay. So I'm going to pull up mine here. Okay, but there is a very particular way to set this up. I had to create this environment. Nothing actually seemed to be working correctly, trying to create a live environment. And I didn't want to hand people a 20 gig machine and say, here, install this. So I went through oops. Let me shut that down. I went through a bastardized way of creating one and wrote a program to actually create a live environment. Hence why there's a script in front of you. Instead of just saying, hey, boot this ISO into a virtual machine, it actually has to be within the parameters of what's on that paper there. Because it's asking for very particular items. So let me... Okay, so how well can you guys really truly see that? Probably not very well at all, huh? Okay, there is no way for me to zoom in on that. Memory is 4 gigs. Processors, 4. That's kind of the start for the big one there. Under processors in VMware, so 4 cores. If you're running a 64-bit machine, you should be able to hit 4 cores without any problem. This middle box here is virtualized Intel VT and some AMD's VT. That needs to be enabled. I'm sorry you guys can't see that all so well. And then your hard disk. At the end of your hard disk, you should see SATA. If it says anything other than SATA, blow it away, recreate it, and create a SATA drive. It's one of the options that you select when you're actually creating a new CD-ROM. Let's see. We're not going to need the internet for any of this. The USB controller, you'll need to set it to 3.0 if you have 3.0 capability on your machine. Let's see. I do recommend that you have your sound card, but make sure you turn your sound down because if we start taking a look at the radio spectrum and your sound's all the way up, it is going to scream at you, depending on what you're listening to. You don't necessarily have to have a printer and then display. Make sure you turn off your Accelerate 3D graphics. Alright. Dang it, I did it again. Stop. Yeah, by the way, under your CD drive, you want to make sure you actually load. Oh, come on. Let's see. This is going to expose.
What tools are you using?
For the class, we're going to use Universal Radio Hacker. We're going to use GQRX. We're going to use no, I took that out. Other stuff. We're going to use Spectrum Painter. The last lab in here, we're actually going to teach you how to transmit a picture into the RF spectrum. I don't know if anyone saw that at if you went to DEF CON. They had it constantly scrolling through in the wireless village. So if you saw a spectrum analyzer, if you pull up the frequency on the spectrum analyzer, you can actually see the DEF CON logo as it would look, which was pretty cool. Hold on. I hope that doesn't disturb his recording. Sorry guys, I have to go into a folder that will expose information I don't know what. Hopefully that comes up there. There it goes. Okay, does anybody have any problems with the instructions that were on the table? Or problems with the ISO itself? When you boot it up, it will take a while. It is an ISO, but it's different than the normal Ubuntu. It actually has a unique live system that was built for it. So that squash, instead of just one squash FS file, it actually has 3. So it does take a little bit longer to decompress the image. You can install it if you want to. I don't recommend doing that right now, as the install will take let's see. Come on. Almost there. Almost there.
Is it normal to get an error that says system program problem detected?
No, that is not okay and not normal. I think you should be having a problem too.
Yeah, is it doing this? Mine just, it is doing 2. And
Are you on virtual box?
I'm on
So let's go take a look at your settings. So I actually did build in time to this for specifically for troubleshooting all your problems. So let's go ahead and cut that down. Okay.
We also get free access for USB
2. TV agent.
have you got it better?
I think so.
No, I still don't think there's actual TV stations up there. Buchanan's in the middle of nowhere, as far as television broadcasts are concerned. But I was just decoding pager traffic, and it's creepy.
I bought this a while ago. I haven't done it.
No? I like it.
Not here. Came with it. Oh yeah, it did.
Really?
It's
It's kind of
a tiny one.
That I should have the image connected to the CD.
I bet you did.
I just swap them out as lingo.
For some reason, I didn't want to go up now. I've been running this for 2 days.
What's that?
Gotta be kidding me. Hooray for the demo gods.
When I checked, it was for.
Did you just sit at the street for a while?
When I was doing it wrong. Yes.
It shouldn't take more than 5. Did it come up for anybody?
It came up, but I'm getting an error message.
Mine seemed like this.
System
Not the
program
first time,
problem
but
detected.
Once I followed the directions to the T.
Okay. Hold on just a second. I'll be right there.
Right here. Directions.
That's weird. I followed the directions.
You do all the shit all the time.
Yes. Why did you not come up?
It has to be a safe. I even followed the what else there.
Okay. Let me come take a look at yours.
Who's got a cooler than
Let's take a look at yours.
I mean,
Oh, yours came up. Okay, yeah, it's a Java error. It's Java 9. If you actually booted into the Ubuntu environment, and it came up and said, there's an error. It's Java 9. It's just a problem with the kernel. Just go ahead and hit cancel. It's fine. It's not going to impede us in any way. Okay, so what should have come up is the SDR environment, and then here in a minute it'll throw an error for Java.
Should workstation or player make a difference?
No, as long as it's a newer version, as long as it's a newer version of VMware, it should be cross-compatible. Is it still not coming up for you?
Maybe buffer IO.
Okay, so one of the things about VMware, this was built in VirtualBox. So you need to go into settings and then change your display. I'm the largest I can actually set mine is 14 4x9 for some reason. If you count 7 times and hit enter, it magically clicks the apply button. Or you can move it around your screen and figure it out. But that should be, hopefully that's big enough for the class here. So, yeah. Okay. Oh, cool. Rock on. Nice. Shit. Yeah. All right. So who's still having a problem?
If you say install,
Okay, so let's go ahead okay, let's take computer settings information now. You should be good. Let's try and do that. No, it's actually
How was your shawarma?
Good. Where'd y'all go?
5 guys. I missed out last night.
Is anybody else still having a problem?
but I'm trying from scratch.
Hooray for live environment. Hooray for demos.
No, this is have you been here? Bindner?
Okay, Andrew Bindner.
All right. And Andrew.
Anybody still having problems? I know I'm going to have one or two that unfortunately are going to have problems that cannot be resolved. If you're still having problems, okay, let me go over and take a look.
Is it possible to run this?
You can, if you have, I'm sorry, what?
Is Docker container?
You might. I didn't test it.
So let's make him go
Does not want to come up. It looks like anyone who's skinny. Yeah, they just hung there and didn't go anywhere.
So, sometimes I forget where it is. I have to check.
Yeah.
Yours, is this come up? Yeah, you had the error, but yours came up. It looks like workstation is, yeah, it's a workstation problem. I have the free version for VMware. If you have something wrong on your machine, which is like, synthetics, you can try doing it that way, or you can try doing it on the USB. We can get back on the
I can rip the other one. Player, I could put the in-house.
You're not worried about your license?
No, I'm running a free anyway.
Oh, okay. Then yeah, that might be one other option.
I already made it.
It is. Oh, you already made it.
Let's see if we made a couple changes here. We'll see if it's. So most of the stuff
Yeah. Okay. So, to get started, if you didn't get it up, or if you're running, or if you're choosing not to run the virtual environment, there are other applications you can install. Just by show of hands, like anyone not using the live environment. You're not using it. You're not. Okay, so the packages you need to install will be just to get started, and I'll work with you a little bit down the road. First one is install live RTL SDR 0. You need to install RTL SDR. If you have the Hack RF, there's just type in app install Hack RF-star, and it'll install all the things that you need. The next thing you need is GNU radio companion, so GNU-radio-companion, and GQRX. The first thing we're going to play with here is GQRX. So why don't we give it another 5 minutes real quick, and then hopefully we can get everybody up online so we can play in the class. I'm so glad I built an extra time for this. I tried to predict problems, I really did.
Are you saying live demos are hard?
Oh god. So 1 year, or it was 2 years ago at DEF CON, I was at LineCon, and I gave, they were giving away the land stars for anyone who would come up and just do a quick speech for LineCon. So I put together a demo and walked through that, but it was on how to give a live demo. And it was just a funny parody of how do you appease the demo gods, how do you do this and that.
Sacrificing this.
I said sacrifice and in turn offerings of bacon and cigarettes.
Live boot USB works, by the way.
Live boot USB works? Okay, I think that's how I'm going to have to do this in the future. Okay. Alright, so if you missed this first little part, it's not a big deal. There's a lot of explanation on how to use the SDR environment. So by the time we get to the next set of labs, yeah, we should be able to, you should be able to be, maybe we can find a solution. If not, I'll work with you independently and we'll find a solution. But I am going to continue. Alright, so first thing that we're actually going to take a look at is GQRX. So go ahead and open up a terminal window. If you need the shortcut for it, it's Control-Alt-T. And we're going to open up, so do sudo for GQRX. And if you didn't already know, the root password for the environment is, or for the sudo is SDR. Okay, so we're going to diverge into two paths here. One of them being, if you have a Hack RF, your input device is going to be a Hack RF. They should be in your dropdown. If you have an RTL SDR, choose the RTL SDR. In my case, I didn't actually attach my radio, so let me do that first. So, unique thing about that before I even get started, your any radio system that you have, whether it's an RTL SDR or a Hack RF or the Yardstick or anything, even your home wireless routers, don't ever turn it on when the antennas are detached. You can actually cause energy spikes through the inputs. The Hack RF comes with little nodules to prevent the sparking of the energy. However, those aren't actually enabled on this device until you enable them. So if you're going to plug this in, do not make sure that you always have an antenna attached to it. Also, on the side of the Hack RF, if you're using the Hack RF, there's two little blue buttons. One of them says reset. One of them says DSP, I think, something like that. DFU. That's it. I was way off. The DFU is for the firmware, if you're flashing with firmware. So don't hit it while we're doing any of your lab demos, because your hardware will go a little haywire and start trying to reinstall itself. So, ooh, I have sound. All right, let me cancel that out. Okay, all right. So you can see that mine came up with the Hack RF. At least I hope everyone can see that in the back. I can't really make that. I can't zoom in on it. Unfortunately, it's not a regular terminal window. The device string. If yours did not come up, do an LS USB and check and see what your firmware address is. When your firmware address comes up, this is the last 6 of the firmware address. So you would just change this from Hack RF to other, and then set Hack RF equals the last 6 of the firmware. If you're using a Lime SDR, you're going to have to do the same thing. Run LS USB, grab the last 6 of the firmware ID, and it would be Lime SDR equals, and put that in there. The input rate. Okay, so there is some slight confusion about input rate. Sorry, so I'll keep myself loose. The input rate for GQRX from the Hack RF actually controls bandwidth. But if you look down here, it says, hey, look, there's a bandwidth here. Well, it's because it's not just bandwidth, it's how many samples we're taking per second. So if you see down in the little gray box underneath, we have sample rate 8 million samples per second. Okay, we're actually going to drop that for the class. We're actually going to drop that down to 2. But the first time through that we do this, even with your RTL SDR, go ahead and, or with the RTL SDR, if you're using that, set it up to 10 million. And if you're using the Hack RF, set it up to 20 million. Decimation is kind of advanced, but if you're having a lot of signal bounce, signal noise, you can actually cut those samples in half and still look at the full bandwidth. Otherwise, you really don't need to play with it. On any normal given day, it doesn't need to get played with. The LNDLO, that's for offsetting the frequency. You don't need to do that at all. So your sample rate from the audio output of 48 kilohertz. 48 kilohertz is just a nice, comfortable setting if you have higher end equipment that can handle it. If you're really involved and getting into a lot of stuff with the SDR, you might choose to go a little higher if you need like a little more crystal clear sound. You have audio equipment that can actually handle it. Okay, so let's go ahead and just click OK. And that'll start up the environment. Okay, so it's not actually running right this second. It's in a paused mode. So over on the far left-hand side, there's a little start DSP. And now we can see the spectrum. So I don't know where your guys came up. Mine came up at 14.2 some change megahertz. And we can see there's kind of sort of some energy that is coming through. So anywhere in the waterfall display, or this is the spectrum display on the top, waterfall display on the bottom. Anywhere where it's configured here in the blue, it's just kind of open air. It's dead static. There's nothing really there. What we do have is all these little white lines that are coming through, and the brighter these get, by default they're going to go to red. We actually have different types of energy on that circuit, or on that frequency. Excuse me. So we can see somewhere here around the 19.792 megahertz-ish area, there seems to be some kind of signal that's actually up here.
Not being large, I'm not sure.
You might actually also notice there's
He's a mover.
a very key thing here in the center. There's a giant spike. No matter where you tune to, that giant spike is always going to be there. That's actually due to the power line into your device. Doesn't matter if you have the RTL SDR, if you have the Hack RF, it's going to be there. I'm going to show you how to turn it off, but for the most part, you just need to remember that this is here. The big reason for that is because if you put your signal dead in the center here and you try to record it, you're going to get an energy spike through the middle of your signal, and it'll destroy your signal. You won't be able to do anything with it. So what you'll want to do is make sure when we go to record signals, the traction just a little right or a little left, but I'll instruct you through that. Okay. Alrighty, so we had set the initial sample rate of the Hack RF at 20 million samples per second. At 20 million samples per second, you can see here on the far left I've got somewhere a little less than about 5 megahertz, and it goes up here to about 25 megahertz. So you can see it kind of controlled, even though it says samples per second, it actually did kind of control the full bandwidth. However, if we try to listen to anything here in this range, it doesn't come in all that clear. So using a very high sample rate, or the highest sample rate your device can handle, can let you go through the spectrum and see a lot more. So you can see a little more to the left and right of wherever you want to try to record. And so you can actually see more. So visually it's nice, but audibly it sucks. So what we're going to do is we're going to change the sample rate down to something that's a little bit more manageable for our hardware. So go ahead and go up to where it said start DSP, and we're going to stop. The next little icon over is configure your I/O device. And instead of a sample rate of 20 million or 10 million, Hack RF, please set it at a sample rate of 8 million. And if you have an RTL SDR, please set it at 2 million. If you're on a line SDR, please set it at 1 million. Yeah. I could be wrong about the Lime SDR. Don't hold me to that. Okay. And we don't need to make any other adjustments besides that. Come on. Stop. Hey. Stop. Of course. Got a window here. Stop. So mine actually, my screen froze. Give me just a second. If yours freezes, just restart it. Okay. All right. And then you can go ahead and start your DSP again. All right, so depending on whether you set 8 million, 2 million, 1 million, it shouldn't be the 10 or the 20 million for the sample rate anymore. If you go back and take a look across your spectrum here, it's somewhere about 10 to somewhere about 18. So it actually did shorten down our bandwidth without us having to play with the bandwidth parameter. Once you get down to a certain level of samples per second, your signal will actually degrade. If you have power issues, if you have faulty hardware, those can really play havoc on your signal recording ability. So you'll want to come up to about 2 million or the 8 million, somewhere in there, and then start playing with that bandwidth parameter and shrinking it down. If you need to get a better audible signal, you'll shrink down the bandwidth just for the sake of recording and then put it back. All right, so to control the frequency, we're actually going to use the numbers up here. If you click up above on top of it, it'll cycle one number up. Click down below on the bottom of the number, it'll cycle down. However, if you just hover your mouse over it and actually type a number, I don't know if that's here, but that's my local country station. So that's not actually here. But if you just type through the numbers, you can actually control it this way. So this will actually set our center frequency.
You do 1051.
Huh?
1051?
1051. Okay, I'll tune it to 1051.
93.3 is the station in this area.
Yeah. 105. Stop that. Stop. Use. Okay, fine. 1051. Okay, but I couldn't get it. So let's just walk down the line here.
102.7 is another one.
Just saying to play classic rock.
Cool. Nice. 1027.
What's that?
1027 is working better.
Okay.
Why?
Also,
you
you might notice there's if you click inside the spectrum analyzer, it gives you a little red line. Wherever you click with this little red line, we'll change that number. So just be careful. So what I like to do is just come out here, and I usually go to the right or the left of my signal. In the receiver options. So if you're not looking at the receiver options is the middle button on here. And we're going to change this to 150 kilohertz. Yeah. Or, sorry, 250 kilohertz. There it is. So now when I actually change the frequency, I'm actually centered on that frequency. So you said 102.7?
Yeah.
What's this station over here? That's 100.1. Yeah, 100.1, 100.9. And there's another one down here somewhere. Oh no, I'm on top of a station here somewhere. I don't think I can get that. Now I want to show you a really funny trick with all these things. So you can see I have, over here I've got one signal that comes in pretty well. I mean, it's coming up as a really strong bright yellow, right? That line down the center is my DC spike. That's the direct current spike I was talking about. But just to the right of that, where I've tuned in my radio station, see, it's not coming in so well. Just a funny little trick. You can actually become part of the antenna. Everyone reach out and go ahead and grab your antenna. And take a look on the screen. See, it comes in a little stronger. So if you're actually, if you're having a really faint signal and you're trying to get it and you need that little extra distance, add yourself to the circuit and you can actually go a little bit farther. Just a neat little trick. All right, let's go ahead to, okay, so let's talk about the actual input controls, and then we'll start walking down. So tune into any radio station that you want, and we'll just do this as an audio thing. Okay, so the LNB, LO, if we were actually to play with this, we can offset a frequency. I haven't talked to anybody who actually ever needs to set this unless they have broken equipment. The crystal that's used on the board to maintain the frequency and oscillations, those can actually be corrected here through frequency correction. And it's usually, I mean, that's just changing just a few hertz at a time. But if your signal, if you're maybe you've got a really bad manufacturer for an RTL SDRs, it's registering, like you try to put it in 106 point whatever, or 102.7, and it's not there. But you find the station broadcasting up up by 5 megahertz. You can actually change the LNB-LO to 5 megahertz, and it will shift everything there. So you can see if you look at the waterfall, you don't need to follow along, but if you look at the waterfall, we can go up, and if you take a look on top of the spectrum, everything's changing, but the signal's staying the same. So also, if you happen to be doing something where you would like to take a picture and you do not want to expose where that signal actually came from, you want to mask it, you can go into your LVNO. Just make sure when you take a picture of it that you mask that out, otherwise someone can tell exactly where it's at anyway. They can just do the math real quick. Okay, the next one down is hardware automatic gain control. Personally, I don't like to set this myself. You can. It's supposed to be a smart, intuitive way for your equipment to balance out if a signal is too high or too low, if there's too much fuzz, if there's too much bleed through from the RF spectrum, you can correct it, or it's supposed to correct it for you. I don't think it does that great of a job in any of the programs, and after as many years as I've been doing this, I find it's just easier to do it manually by hand. However, you can set this. If you have an RTL SDR, it's really not that bad. If you're tuning in just if you're out in the field or something and you want to just listen to the radio, it's really not a bad setting. But if you're playing with a piece of, if you're playing with an IoT piece of gear, and you're trying to intercept the signal that's coming off the board, or remote control or something like that, you'll probably want to set the gain manually by hand so you can get the best quality signal. In this case, though, what we're going to do, let's just go ahead and play with these. Let's see, I'm going to do, of course I'm not, because it's not going to let me, right? Wrong button. Okay, so if we turn up the RF gain, that's how much RF energy are we letting in. That's the actual, that's like, that's no different than cranking up the master volume. So we're just allowing more of that to come in. The IF gain is an intermediate frequency. This is how much are we going to give it extra. Think of it like maybe you had speakers that had like boost based, so like when you hit the button instead of going boom, boom, I don't know. I had a brother who was really into all that stuff, so I used to make fun of him like crazy for it. I never had a pair of headphones like that, but I know they were made. So that's what IF gain is. The baseband gain is allowing the floodgate open more. So we can actually take all that signal noise off of the baseband, or all at the bottom side of the frequency, and raise it up. So you can see if we took the RF gain down, on the Hack RF, it's either basically an on or off. It goes from 0 to 14. There is no intermediate step there. So I usually just turn it on. The IF gain, you can play with this, but one of the things I want you to pay attention to is the baseband gain. So as we turn up the baseband gain, see, everything comes in a whole lot louder, doesn't it? But magically, look, I've got some kind of station that's over here. It's actually pretty loud, but you didn't want to come through it first. So you can see if there's other things, maybe like, okay, well, I can see it's in the spectrum, I'm just not close enough. Or there's some other kind of interference, or maybe my gear needs to be reset, something like that. So you can actually tune in, help tune in that way. I'm going to take this back down. Okay. Alrighty. Let's see. The last thing here is the antenna. Down on the bottom right hand side. And that is, so the antenna is TX-RX. If you have an RTL SDR, it should just say RX. It shouldn't say TX. Oh, I totally got to tell you how to get rid of that stupid spike. The stupid spike that's here is DC remove, that direct current remove. So if you just put a little check mark in the box, it should just die away. As such, and it'll eventually go away. Just because it's not visually there though, when you go to record a signal, it's there. So if you turn it off, just remember that it's there.
He just removes the spike from the picture.
Yeah, it just removes the spike from the picture. It just kind of shuts it down a little bit. The swap IQ actually will invert the whole entire spectrum. There's, I guess if you really wanted to do it, you can. It's not, I guess it's a user preference. I don't even know why it's there. No limits. This is what I do want to talk about, though. So the Hack RF in particular, I don't know what anyone else's RTL SDR because there's so many different makes and models. But especially with those, there's a particular range that they were built for. This was built for 1 megahertz to 6 gigahertz. Mike Osman specifically came out and said it can go above and below that. I don't know to what the extent those are. I haven't needed them before, but you can go above that 6 gigahertz range and below that 1 megahertz range. By specifying no limits, GQRX will allow you to go past the 1 megahertz. It'll let you go beyond the hard stop that it has. So if you were at, if you were just scrolling through and as you get to 6 gigahertz, GQRX will actually stop you. It won't go any further because it's programmed for your hardware. So if you specify no limits, it'll actually let you scan beyond that. The hardware is capable of going up a little further past that. You'd have to go check on Great Scott Gadgets what it actually is, or what it is below that 1 megahertz scale. It is possible though.
Is there any reason not to do that?
Is there any reason not to? Well, once you get to a certain point, then literally all you're going to see is static.
But it won't damage anything.
No, because it's not within its resonant frequency. It will not pick it up whatsoever. Yeah, it's not like it's applying extra energy or anything to the signal to try and listen harder or whatnot. Yeah. Okay, so let's go into receiver options. Pardon. So filter width. The filter width is generally set at normal. We're going to set it at wide. Doesn't really matter right now because we don't haven't really set a mode. Let's just jump down to mode. So demodulation off just allows you to see what's going on. Doesn't have any sound to it. The raw I/O is, if you could increase your hearing bionically, like that's what you're going to hear. You're going to hear the rawness of what's on the RF spectrum at that time. Some advanced signals when you get to them when you're listening to like an FSK versus a BPSK or amplitude. If you want to try to listen to Morse code, you can listen to them raw, and it's a lot easier. Or if you're having trouble trying to find the most faint signal, and you know it's somewhere there, and every other trick that you're trying, you can try by ear to listen in. So the raw IQ will actually let you listen to what's raw on the spectrum. AM for amplitude modulation. If you know you're listening into an amplitude modulated signal or radio station, you can change to AM. We're on the FM network. Let's go ahead and in this case, we're on wide FM because it's broadcast radio. When you actually choose a mode, down here in the bottom right-hand side, your audio screen should give you a picture of what it's actually trying to listen to. It's kind of like a little, it's just a little zoomed in, but it'll actually tell you what the decibel level is. Let's see. Okay, so the automatic gain control, if you had the hardware automatic gain control enabled, you can set how fast it switches between the automatic gain control, trying to keep that signal level. In most cases, especially if you're working on a signal that you know or a signal that you're close to, it's really not that necessary. But it's generally recommended just leave it at fast to save your ears. One of the reasons is, and I actually have tinnitus because of it, when you're listening through the spectrum, as you can scroll through here, you can hit incredible decibel levels to just spike. So you'll be listening through static, and all of a sudden you'll come across a spike and it'll blare in your ears. With the automatic gain control set to fast, it tries to reduce how, as you come across that signal, it tries to actually reduce the sound and keep it within hearing ability. It's really good for your ears. Down on the bottom, I will talk about squelch in a half second, but there's a little A right next to it. Go ahead and hit the A. And nobody should have any sound after it hits A. The reason for that is we notice the squelch went from negative 150, mine went down to 47. Yours may be at a different number, more than likely it is, because it's a sample at the single time that it's there. But squelch is, it's going to turn down the audio volume to us. That's it. It's not actually going to stop the signal, it's not going to turn down the volume. Remember all the gain settings that we played with were like turning up the master volume? Well, this is like if you had headphones plugged into a mix master station and we're remixing something. The squelch actually is just the noise floor which we want to hear. It has nothing to do with hardware. So that signal's still going. I can actually record it right now even though I can't hear it. So if you find something and it's there and you just want to see it, maybe you want to hear it at first, you can lower the squelch. Obviously, the more negative the number, the more the louder it's going to be. So the closer you get to 0 DBFS, closer to 0 is don't let anything through. The noise blanker systems are pretty. There's not really this thing. Okay, now let's have a little bit of fun. So in GQRX, we have both of these windows, and the audio controls over here are actually all configurable. So starting from the top, the FFT size, you can actually change how big or small you want that to be. If you need more definition, so I recommend running it at about at 65, 35, 36. The reason for that is the amount of detail that you actually get in here. You can clearly see if we had to zoom in on something, you can clearly see if it's voice, if it's frequency shift keying, if it's Morse code or on-off keying, and it gives you a better level of detail. And especially if you're taking pictures for reports for clients and stuff like that, it's a lot nicer. The frame rate for the FFT, which the waterfall down here on the bottom, by the way, is called the FFT. If you want to change it to go faster or slower, there it is at 60. Okay. Let's see. Your time span, you can actually set a time span. So let's say I wanted to record, I'm examining 20 megahertz wide bandwidth of signal, and I want to see what's over the course of a half an hour. Like, I know there's supposed to be something here, but maybe I've got to go actually like outside and start a card, see if the immobilizer kicks off or something like that, or walk away. I've seen people with their key fobs actually trying to figure out what the distance of how far they could get away. So they would actually walk, step, hit the button, walk, step, hit the button, and they were calculating out how many feet. But they could come back in here, set the time span to like 30 minutes, and you'll see it takes a really long time to build up that window. So you can just make the window super huge, and then you can record over a great amount of time. So if you just don't know what's supposed to be there, and you just want to go grab a cup of coffee and come back and see if anything came up, or you're waiting for a signal that's really intermittent, then this would be one of the ways that you can see if there's just any energy on the spectrum. Although I'm going to set it back to auto and 30. It doesn't need to go any faster or slower than that. All right, averaging. If you have, if you take the slider and move it left and right, you'll notice we're no longer playing with the FFT display. We're playing with the spectrum display. Averaging, moving it all the way to the left, shows you the actual raw cycle as it's going, or the raw sample as it's going through. But if you needed something, this is the equivalent of if you wanted to just kind of round it out, give it a little bit better look. I mean, especially if you're taking pictures and something's always constantly fluctuating, rounding it out or averaging it out the signal, just make it look nicer. It's all 100% custom. The pan-adapter just raises or lowers one or the other. So if you want to shut one on or off, I usually have mine somewhere about there, just the way I like it. It's personal preference. If you wanted to, if you were having a hard time trying to determine where maybe a peak might be, you can actually do a peak detect and turn that on. And we get these little circles that come up on every one of the peaks where it intuitively thinks that there's a data channel. Likewise, with that, we can actually also hold. That's not going to show up also well because these are actually moving pretty fast. But maybe on yours you can tell a little bit better, but there's this kind of like little tracer line that's above the signal. And that tracer is showing you where peaks are. So another way, if you want to record for half an hour, just want to walk away and see something, if you come back and there's a peak or a couple of peaks, you know that there's something transmitted there while you were gone. Alrighty, I'm going to turn that off. Okay, there is a zoom function if you wanted to zoom in. If you needed to set your filter, this is a really great time. So in this case, the filter actually goes pretty far beyond. So you can actually grab either side of those and move them back and forth, and you can actually grab that filter and move it left and right until you get it centered to where you want it to be. So you can actually filter out what you want and what you don't want. All right, let's see. To reset is R. Under zoom, center would be to C. D is it'll actually move the whole entire thing over. You'll notice that there's kind of this little gap over here on the right hand side. It's not a very nice way to do it, but it'll move it over if you just need to take a picture of it or something for clarity. Otherwise, I'll just reset it. If you want to change the color, you can change the color of your displays. I've got mine as, well, I guess pink is not a really good color, but there's a light blue. Then you can change it to whatever you want, or cyan, you can fill it in. It's just, hey, that's pretty. If you're going to stare at it for hours, go for it, you know? I do appreciate that they did that. Alright. Okay, alright, so enough about GQRX interface. We're actually going to, there's just a couple other things I want to show you really quickly here. One of them is record. If you were to actually hit record, it is recording until you decide to press stop. And that's going to give you a the signal that actually shows up. Let's see if I can change that from, I can't. Well, the signal that actually goes up, because you can replay that back. Let's see if I can do it this way. So home SDR, let's select It didn't change. Where did it go? Where did it go? Okay. All right, let's try that one more time. Record. Stop recording. Yeah, just select the directory. I want to open the file. Okay. All right. So when you record it this way, using that, you can see here that it actually creates WAV files. So if you want to capture a piece of audio and replay it, that's just play it back. This is one way you can do it. If you're listening in on radio, push to talk. If you're listening to drug counter ops, I don't recommend doing anything with law enforcement unless you're actually in the law enforcement field. But if you wanted to play around with recording something, like you wanted to try to decipher some voice or something, or hey, like how do I record this? How do I decode this Albanian thing so I can go find my daughter? Yeah, you could record it to a WAV file. However, this WAV file, you cannot take this into something like GNU Radio Companion and actually, you can't take it into GNU Radio Companion and actually do any processing on the signal. So if you record the signal, you could hear it, you can visually see it, but you can't do anything with it. So when we record back here, one of the things that we want to, all right, I was wondering who the heck that actually was, and I realized that that is me. Let's see. I'm going to go turn that off. Receiver. Okay. That's much better, isn't it? I thought that was one of you guys just having it running. I didn't want to be rude and be like, hey, turns out I'm the asshole. Okay.
Don't you hate when that happens?
Yes, I hate it when that happens.
Sorry, you're not the only one that was thinking that.
What, I'm an asshole? That's fucking. All right. So the other way that we wanted, if you wanted to record a signal in here and then take it later, maybe take it to a lab machine or to a friend's house or whatever and process the signal, or if you want to do it offline later, if you go into Tools and the IQ recorder here, if you go into IQ recorder and you record from here, you'll see it actually came up as a raw signal in the file name. Now that raw signal you can take offline and do analysis on. Alright. Last but not least, there's one last thing I want to show you, and that is bookmarks. For the love of God, get used to bookmarks. Know them, love them. When you set a bookmark, you can actually right-click on the bottom here and then add bookmark. So, I mean, this is the simple radio station 102.6, and I created the tag for it. So now I can see where my radio stations are, and I've got a list of playlists for my radio. But of maybe I found a GSM network or a pager network that I want to listen into, or there's just something really funny here. You can actually tag those things and set bookmarks so you know where it's coming back in on. Also, if you're like trying to find a whole bunch of things all at once, I did work on an IoT device a while back, and it had 3 Bluetooth modules that ran across like 12 different frequencies. It had a wake-up signal to it. It was just a god-awful nightmare. But I had to quickly go and set bookmarks for each one of the signals as they would come by, so I could identify which one. But you can come back in on the frequency, or you can come back in here, double click, and then it'll move everything for you. So you can see here, wherever that red spike was, where we would click in here, it'll move it. So just be cognizant of that, because like my receiver options, it offset it by like 3 megahertz and some change. Alright. Okay, we are done with GQRX. Stop putting you guys to sleep, I promise. Alright. That's SDR Basics and GQRX. We're going to take a 10-minute break. Anyone who needs help with their SDR environment, we'll try to get it up over the next 10 minutes. But please, by all means, get up, stretch, for our class. I don't expect you guys to listen to me really drone on for 4 hours. Go grab a beer. It's afternoon. No one's going to blame you. You're at a hacker convention.
I like it, guys.
Yeah, this one right now.
Okay, so that's let's come back at 3:45.
The candy is there for anyone to get.
Sugar.
What's up there?
Water, coffee,
I can't bring a beer break request.
Yeah. I'll take some.
Once you ask mom, and how long you have been waiting for yours.
I see how you
I got mine, although my audio is very low.
Okay. So you know what? Yeah. There was one thing I forgot to mention, HQRX. Down in my audio window, there's a decibel slider. And there's also another master volume, like something for volume on it.
Okay.
One's for the hardware, one's for the, one's for the
Demodulation, yeah.
Yeah, so if you take that slider in the bottom right hand corner and slide it up, it'll be a lot louder.
Can I take it, do you recommend those?
I have a lot of fun with these, and these were there. So these will actually record and transmit.
Right.
But you can have a yardstick, and RF Cat is fully Python based and huge. I mean, there's a huge set of applications for it. So a yardstick works just fine. But a yardstick costs just as much as this, does a wider range and interface with that. So I recommend these. Yeah. Yeah. I can watch over all this. Do you want to do a picture?
They're not cheap.
Yeah, they're not cheap. That's why I said at the beginning, like this, like if you get interested in this, you can do a lot of stuff with it, but when you start really getting into it, it gets expensive.
Is that the one off the fireworks site? Or,
I got mine straight from Great Scott Gadget. And I think he says, I think his goes out to like Carolinas or something. There's somebody else who does the boards and actually does it. They just like slap the name on it. No, well, there was an original. The original one was just board, and then there was a board with clear case mounting. It was a Kickstarter project, and then the latest version of it has the harder case to it. Small ones.
Are those awesome? Those are awesome.
Honestly, I would be making models.
Yeah, you want to make sense of it? That's cool. What's that?
So what's it like working at Rapid 7?
It is fast paced.
Yeah.
I absolutely love it. Ask my wife. I am a huge nutty professor. They let me be the nutty professor. If I come up with an idea and I'm like, hey guys, I really want to try this, they're like, sweet. How long is it going to take you to do that? I said, oh, I need 60 days. And they go, 45? So, I mean, everything's on a time base. But they're actually really good about projects. So if I say, hey, I've got this thing I want to do this project, they're like, yes, here's some money, go do it. Or in a lot of cases, I don't need that. I just need the time off, which is really cool because we don't have a as long as we keep up our utilization, they don't care how much time off we take. So if I need to take a week for bench time, I can just tell my manager, like, hey, this week or this month, I don't have anything scheduled with clients, so I'm gonna take a week of bench and I'm gonna just totally knock out this project, this idea that I'm working on.
Yeah.
And they're like, yes, absolutely do that. But they're a big proponent of family. Like if you're not happy with you're not happy at home, you're not gonna be happy in the workspace.
Yeah.
So they give us a lot of freedom to spend time with our family. Like I have my wife and stepdad here with me this time, and it's an absolute blast because like even the keynote and then I think it was Ernest Wong from the U.S. Cyber awesome dude.
See, I told you we should have grabbed up the drive.
You know what? We tried to hit the store last night when we got in, and it was like closed. And we came back in the bar, and I'm staring at my phone. It says 23:59, and they're like, "No, we're already closed. Our clock's at 11." Like, it's
bullshit right there.
Like we just want a glass of wine. We just drove 6 hours to be here.
So for the rest of the labs, are there any actual like SDR files we need from the guys that are
Nope. No, absolutely not. We have this nice Chicago wireless light switch. We're gonna come. We're actually gonna do a replay attack with that, and we're gonna actually take a look at the ones and zeros. We have key fobs. We're going to work with key fobs and then talk about what things actually play with those codes. We're going to talk about different types of orders. So I think we'll be calling it a lot of people want to see how do we get into advice, like RF. That's not going to be in this class. Remember I showed you that.
Come on!
Remember I showed you that the beginning slide was like your expectation versus reality. Yeah, we're just testing each other's.
People like them. I can't.
What were you? Navy?
I was Navy. I was Navy for 15 years as a cryptologist.
You left where were your stations?
I was all over the freaking place. I did San Diego, Point Loma, I did Milton, Florida, Pensacola, Florida. I worked in the Navy Yard for a while. I've been up at the fort. I used to, so my reserve job was up at the fort, but my civilian job at the time, because I was a reservist for a while there, was working at the Office of Director of National Intelligence, ODNI. And so we go play with all of the different races. We were the certifying authorities for CI, Alphabet Soup agency.
Oh yeah.
We were everyone up in that area. So
you were there. You were in for 15. You said.
Yeah, I was medically thrown out on my butt. I even went to the Marines and they wouldn't take me anymore. And it's the stupidest thing. I have sleep apnea. And they went, no, you can't play anymore. Why? And they're like, because you require sleep apnea. And I'm like, huh?
Did you do the study for the VA for that?
Yeah. Yeah, and it's instantaneous disqualifier. Like, I was like, well, can I get the surgery? Can I do, whatever? And they're like, no, you're done.
Yeah,
and I was heartbroken because I was going to pin on Chief. And they had stopped the whole entire process, and so I had to get out of Z6.
That's
Yeah, it sucks. But it is what it is. I enjoyed every minute of it, and I would happily go back to it if they would let me in.
Did they medically retire you, or just medically kick you out?
I dropped on request.
Yeah.
Yeah, it was at that point. It was I was getting in trouble for because I was on limited duty, and they were in the process of trying to determine whether I could get out, stay in, get out, whatever. So it was like I show up for duty, and I have to go over to a different Air Force base for medical, and everyone else would already have started the day. So by halfway through the day, here comes in Soldier Bindner. Like, where the hell have you been? I've been at medical. Like every freaking time for the last 6 months, and so it was getting to a bad spot. I'm like, yeah, you know, guys, I'm just gonna leave. Yeah, it was what it was. So I was happy to get out, but I'd be happy to go back in. I missed some of the work. I worked in some very sensitive spaces, and I know things that would make most people's hair curl.
That's the shit I love.
I was in the Marine Corps for 4 years, machine gunner, and it was so much fun. I miss it like every day.
There's a level of camaraderie there that you cannot. You can't really.
You can't get it anywhere else.
Yeah, you just can't get it anywhere else. Hiking. Yeah. What's it? Oh, I'm good, honey. Let's see where we Oh, I think. I'm gonna give him a few minutes, but I think I mistook the clock, and I think I actually put everyone on a 25-minute break. So I said 3:45, which is still another 10 minutes. I'm like, that should be already done. Yeah, just gotta get ready. Yeah. The next. Thank you, sir. And you?
Justin.
I appreciate that. Thank you.
Isn't it?
I've
candy
always been on that side. This is the first time I've been up here.
Well, I'm enjoying it. I learned, EQRX, the bookmark thing alone is what comes in.
There are so many just little nuances all over the place.
Well, usually the bookmarks are right down here and then look for that scrap of paper that I threw away 2 weeks ago.
Yeah. My other buddy who actually has his set up where he's got a little art. He works with the Hack RF one and the yardstick, and then he's got all his Bluetooth adapters and stuff as well. But just for his little RTL SDR, he's got all of the radio stations set up at all of our different locations, all of our headquarters. So every time we travel to one of our different buildings, like, he can immediately pull it out and he remembers exactly which stations were his favorite. He's got them all full marked. Sometimes it makes your life. I'm seeing the majority.
Still out.
I think.
Not the majority. Couple.
Yeah, he grabbed his bag and never left. So yeah.
Okay. There were two other gentlemen with you that still see their laptops. We'll give them just a couple more minutes here. We're not running behind anyway. On the phone. I'm just stick my head out here and see if they're out.
I like the breakdown of the electromagnetic wave, though. That was nice. So easy, you can teach it right to a kid. Real nice.
I think it's a smaller one.
So you recommend the Hack RF over any of the other stuff?
I like the Hack RF. It's easy to use. Its documentation is really good. If you wanted to use it for heavier signal processing than what we're doing here, Mike Osmond has an incredible series. He used to go around to all the different conventions and teach the course over multiple days. I guess he must have got tired of it or something early because he recorded all of them and put them online. So no more course. Alrighty, ready or not? I guess I'll have to come back in when we get going. So I'm gonna get going. All right. So up to this point, we've gone through some labs to experience what the RF spectrum actually kind of looks like. How do we navigate through it? Now it's time to talk about what are we actually going to use this for? The FCC actually controls everything that gets transmitted. They're the ones that actually set all the frequency designation, hold all the laws, do everything like that. But they're also this wonderful entity. If you're doing any type of testing, they also mandate, or they also control the FCC ID numbers. So anything that transmits in the United States has to have an FCC ID number. Everything from your car keys to your microwave Your microwave doesn't even send a data communication, but it does radiate at a particular frequency. So even your microwave has an FCC ID number. If you have a Bluetooth-enabled coffee pot, it has an FCC ID number. So anything that transmits, I'm just going to beat that with a dead horse, anything that transmits has an FCC ID number. The FCC, most of what we want to play with is in the ISM, or the Industrial Scientific Medical Band, I believe it's called. That's going to be a lot of the stuff that we really want to play with. In this particular field, it's medical equipment and consumer electronics and scientific gear, and some air-gap type systems for SCADA. A lot of fun stuff can be found within the ISM spectrum. There's the airband. I did not include in here, especially considering this building, anything on ADS-B, which is tracking airplanes. It's been beaten to death online. Hack5 did a great multi-part, like 5 series years ago for it. And so if you want to track airplanes, you can, but there's particularly a set airband for it. There's bands for broadcasting and marine control. With marine control, I mean anything out from port harbor masters to our Navy. Everything has a particular band. Amateur radio. Okay, so there's 2 really important pieces here: amateur radio and citizen and personal radios. Citizen, you might also see this as the citizen band, or CB. I'm sure everyone has more or less heard of CB. Breaker 2419 are coming. Like, you don't have to have a license to operate on that. You can literally throw it in and jump in the fray and just start talking, and people really can't shut you up. So, go for it. Have fun with it. Some truckers have some really great stories. I mean, even if they're fake and you can't prove them, I mean, sometimes it's fun listening. The amateur radio. Amateur radio is, it's not just because you're an amateur you get it. You actually have to have a license to participate in that band. It's usually considered the ham radio. Or there's the ARRL, it's a radio lead. But you have to actually take a test. It's like a $15 test. I think they're doing it on Sunday. Actually tomorrow they're actually having the class that preps for the test on Sunday. So if you're interested in getting your ham radio license, then you can operate in the radio frequencies here. Remote controllers, anything with a remote control. So if you have, let's say you have a drone, okay, and you have the controller, that's going across the RF spectrum. Well, what if you have inside in your house, you have, let's say, a Harmony Life remote, or just a regular TV remote? What sensor does that use? It uses IR. IR is infrared light. So it actually has a frequency and broadcast. It still has an FCC ID number. Little known fact, if you go to the Hogwarts land,
In Disney World?
No, it's not Disney World. It's Universal. The little wands have IR sensors in them. If you buy them, they're like $50, and you can go all across the park and you can do stuff. Well, it's just an IR sensor, so you can actually create one too with a pie and replay it and go through the park and do all the stuff and not pay the $50. I'm sorry, Universal, if they're watching. Sorry, I'm not sorry. Radar. I think that everyone should actually look at radar. If you don't know how radar actually works, how cops nail you with speeding tickets, you should really, really go read up about how screwed up radar is. But it has a very particular frequency. That's why we can buy jammers. They're illegal. They're illegal. But you can buy a jammer, or you can make one yourself. They're illegal. You can have some fun. Two-way radio walkie-talkies. Now this has got to be one of my favorite, just to mess with somebody. Now keep in mind there are some legal ramifications for doing this, but if you are going to go, say, do an on-site physical penetration test of a company, and they use push-talk radio, if you figure out where that band is, which radio system they're using, you can record voice and then replay it at the same frequency. So you can get people to like go away. You can get people to go all over the building. Or you can just make your own recording and transmit it on that same frequency, and you can have a lot of fun with this. Or if you know that, when I was a kid, we had radios and we would listen in, and we had push talk walkie-talkies for that would span like a mile, and it's okay to use those. But every once in a while, we hear like the weirdest things. Like somebody would come across on that same channel because it was just like the Walmart little $10 special type radio, and all of a sudden you hear, just randomly you just hear just stuff. Or people would just come on and start like spouting the time while you're trying to have a conversation with somebody. Or people would say, "Shut up, you're boring." You can have a lot of fun with walkie-talkie. Cellular communications. Cellular communications are getting tough. You can get onto GSM networks and start pulling packets and start examining and seeing what's going where. But actually getting into the communications for those is very, very difficult. Not only do they use time division multiplexing, they jump in frequency. They use frequency hopping. So you may get a quarter of a packet, and even if you could magically decipher that and actually pull out voice, you get a split-second voice, and then you get another call for a split second, and another call for a split second. You wouldn't actually understand it because it's the full data packet that has to arrive at the phone and then be reassembled. So cellular communications are their own unique beast, but they have their own particular band. It's in the 850 and above. Search and rescue. I don't know if I can harp on this without getting a little misty-eyed. I'll try. Search and rescue is really important. All park rangers, all military, all anybody at port, if there's Port Harbor around, firefighters, ambulances in some cases, if there's base stations set up, a lot of radio stations, they all listen in on search and rescue. If you ever get lost, if you know what your frequencies are for search and rescue, you can always tune in and start talking to somebody. Eventually, they will find you. This can save lives, and it really does make a huge difference. Search and rescue, where I live, where I grew up in North Idaho, people used to walk out into the woods and go snowboarding or go hiking, and thank God we had SAR, because you can go across the frequencies, and I don't know where I'm at. Well, they make communications here that says, okay, well that person is in that direction, so they get people up all along the ridge and actually shoot a line of bearing from, okay, I've got him and he's at 270 degrees from my location. I've got him and he's at 60 degrees from my location. I've got him and he's at 180. Those three lines that intersect will tell them within just a matter of feet how right where you are, and they can come and find you. They can come and get you. For professional skiers and like the adrenaline addicts, their body gear sometimes contains emergency broadcast equipment. If they get stuck in an avalanche or they get buried or something, it'll automatically go off and it'll send a SAR beacon with the actual GPS coordinates to the mountain makers. So SAR is really, really important. If you're out in the field or if you're out on the water, always know what your SAR frequencies are. Okay, all right. So if we delve further into those bands, got off my soapbox about SAR. If we delve into the actual RF bands, there's many different ways to label them. Most of the time, people are just going to pay attention to the numbers, which is the frequency on the left-hand side. But you can see that on the far right-hand side, we have the ITU abbreviation from extremely low, super low, ultra low, so on and so forth, until the tremendously high frequency. That's where everyone wants to operate. Doesn't everyone want to be tremendously high? Or that's Colorado? I'm a dad. My jokes don't get any better. But depending on who you're working with or what type of gear, I've had some clients say, "Oh, well, we have signals and they operate in the X band, the K band, the L band, the whatever." There actually isn't an, yeah, there's an X band there. But you have to have gear that'll go up that high Right now, the Hack RF only goes up to here. So there's still a lot more that we can't even begin to take a look at.
How common is signal in that range?
What was that?
How common is signals in that range?
Glad you brought that up. Thanks, Liz. So the extremely low frequency to the super low frequency, one of the big things that I have a lot of, that I've always just remembered, was it's submarines and mines. There is other stuff on these networks, but I mean, you're talking some really low stuff. Let's see. So you have the very low frequency subs, navigators, heart rate monitors, geophysics. If you have compasses for, say, a ship that's at sea, the gyroscope that actually keeps its balance and keeps its heading. So it has, some of them have radio frequencies that operate in the VLF. And so they actually pull GPS signals and stuff. LF, navigation, time, and broadcasts, RFIDs, amateur radio. Amateur radio is actually in multiples. Medium frequencies, avalanche beacons, those are always fun. Let's see, so the high frequencies. Okay, I've got this labeled as too much to list. The high frequency, there is so much consumer electronic stuff that happens out on this frequency. There is a lot of fax machines and weather stations and I can name it. There really is too much to go. If you go out to the internet and actually Google what's on the HF spectrum, it's just page after page of just stuff to go have fun with. So I spend a lot of time in this range of looking for things. VHF and UHF, TV, broadcast. But once we cross over into UHF, we started getting into the really fun stuff. Bluetooth, GPS, Zigbee, satellite radio, ASB is also up there, two-way radios. The reason for these, as we've noticed, as we get smaller, these signals become a lot more closer and near and dear to the products that we actually use, right? Submarines, these signals have to process through water at miles, for freaking miles, and they need to get to their destination wherever they're going, where they have to go through, miles deep of water. I honestly don't know how deep a sub goes. I'm pretty sure actually that's classified. But as we get to, say, UHF, TV, microwave, Zigbee, satellite, do we want Zigbee signals to go all the way to my neighbor's house? No, I don't want him to control my stuff. I just need it for inside my house. It's really short range. That might be at the higher end of the UHF spectrum versus the lower end. But you can see as we get going down, the frequency is getting faster. This is getting higher. So we get into the EHF. Yes, this is fun. Body scanning, imaging, and X-ray. So when you go through the airport and you actually stand there and do, well, probably not. Most of you guys probably have the pass to walk on through. If you don't, just for the love of God, get it. So the body scanners. I'm pretty sure if you went to the airport and you sat there with your laptop and an antenna, you could probably pull images that are being scanned. I'm pretty sure you would also be arrested, or at least have your gear confiscated, because you may be able to sit there and go, "Yes, sir, this is just for research. I'm outside the security point, whatever." They're going to be like, "Fuck you, I don't care," and they're going to take your stuff. Because they're just going to take stuff and not ask questions later, and good luck trying to get it back from them. The tremendously high frequency, you're talking like nuclear medicine. Yeah. That gear is going to cost you multi-million-dollar, just to try and get onto that frequency. So I don't know. Why not? All right, so enough about the RF spectrum. Next slide. Okay, hardware. So the common hardware, this is just the stuff the pictures are just the stuff that we are talking about for today. But I'm not going to read this out loud to you. Common software, I do want to make a point. RF Cat here, Atlas wrote that specifically for the RF sticker. And that's so you can transmit signals with that. GQRX we played with, GNU Radio Companion is interfaced like all of these. Are these three, GQRX, GNU Radio, and Universal Radio Hacker, and SDR Sharp. SDR Sharp is the Windows version of GQRX. But all of these operate with so many different types of hardware. Also, if you're having any trouble, just Google. Google is your friend. If you go on Google, you can actually pull down recordings that people have made from all across the world. You can listen in to other people's RTL SDRs. They actually have a site where people have donated their equipment, and like you want to listen to, I don't know, Swedish ska band or whatever. I'm sure you can tune into an RTL SDR out in Sweden. And you can just listen in on the radio. Maybe you speak German or you're trying to learn German, so maybe you want to listen to the news broadcast on an AM station with an RTL SDR in Germany. So you can try and pick up the language a little bit more. I mean, you can do lots of stuff. But there's Google. I mean, people will walk through how to demodulate the signals that they've recorded and do tutorials and stuff. So it's really powerful. So you don't even need hardware at that point. You can just run it all through the software. And I mean, if you're on an airplane or something and you download everything, you don't need it up and running. Basically. All right. Every piece of hardware has an antenna. Antennas shape and focus the RF waves. Most common one, parabolic dish. Everyone see the satellite dishes on people's homes to try to get like dish TV and stuff like that. If you find one of those, not currently in use by your neighbor, not that I would advocate stealing anything from them, go get one. If you find one at a junkyard, go get one. If there's just one randomly in the field, go get one. They don't go bad. You can clean them up and reuse them. But you can actually hook up a parabolic dish to just a regular antenna, even off the Hack RF here. You can make your own and just get a proper BNC connector or Type F connector, whichever one that is. And then you can hook it up and you can start pointing it. And that parabolic dish will actually allow you to shape what RF energy you're bringing in. You can extend Bluetooth by like a block and a half. I mean, there's some neat stuff that you can do with it. Anyway, so antennas transmit or absorb RF signals. And based on their shape, size, etc., they provide different levels of gain. Just remember as we were looking with the when we were looking at GQRX, we had a gain. We could actually set the physical gain. The gain was either 0 or 14 because that's the limitation of the hardware. But the initial amount of what can be heard, like kind of like a bionic ear, right? It's measured in so the higher the gain or the better the gain, the more you can actually hear without processing any of the signal. You can make your own. We had fun making our own, didn't we? Yeah, we made a 50-foot whip antenna. We went down and stripped out 50 feet of copper cable and spun it, and then we had it horribly jacked up on this pole that was all like dangling, but it was for a science project, and we did it, and it was fun. We had a little, radio kit built it, and we couldn't hear anything without an antenna, and we figured out where to actually touch the antenna to the board. And we got like Mexican radio.
Yeah, we got Mexican radio.
Oh, and ESPN. We got ESPN on AM. Not that sports is a really big thing in our house. No. All right, but yeah, you can make your own. And so antennas come in all shapes and sizes too, all funny things. What? Oh, okay, it's bow ties. Okay. It just did look funny because it was sideways. They literally do come in all shapes and sizes. Generally, if we started to take a look, next slide. When we start to actually take a look at different types of antennas that we may want to have on hand, we generally are going to either end up with an omnidirectional, or an omni antenna, or a directional antenna. An omnidirectional antenna, literally radiates out in a circular pattern around the antenna. If you could put a donut on your finger, you could eat everything off your finger, right? You can eat the whole donut all the way around. So imagine that's your data that's coming out. What you can't eat is the core and the tip. So there's no actual broadcast from the tip. This, for instance, is just a little whip antenna. This says this is an omnidirectional antenna. The radio waves come out, but they can come up at an angle, slightly down, whatever. But they don't actually come straight out of the tip. So if you were to just point this at somebody, it's not like you're like, I know my signal's coming from there. It doesn't work. That is the point of a Yagi antenna or a directional antenna. And those ones, they're actually tuned to very particular frequencies. Not that it means that you're only going to listen to that one frequency it's set for. It usually has a pretty good size range, and as long as you're pointing it in the general direction, you can do lots of fun stuff with it. Just recently, as I was driving through my hometown, we started to look at all the lights. And all the lights, as we're going through, we noticed that up on each one of the corner posts of the lights, there was a Yagi antenna that actually pointed to the next light. And so you go up to the next light, and there'd be two Yagi antennas, one that pointed back and one that went up the other way. So, I bet you could jam that signal. Not that I'm going to. You could jam that signal and actually and probably mess with those lights, or at least interfere with their. I'm going to guess that it's on a network. It's being controlled over the network, and that somebody has control over those lights. They probably default to something or other if they lose communication. But you theoretically you could by taking a picture of that antenna, you could say, okay, well, based on the Yagi antenna, it's got prongs that are this tall, therefore it probably operates in this type of frequency. You can make a lot of assumptions and probably find the communications network for the light system that's in my account. Directional antennas come in a variety of shapes, sizes, patterns, mostly for covered areas. Let's see, so there's cones, there's bat wings, there's all kinds of stuff. But if you've ever gone down to if you've ever gone out into the woods and you have to have you see up on top of people's homes like the directional antennas, most times you're going to see a Yagi, and they usually point towards one of the main towers. The big thing is you have to get up over the trees just to get that type of thing. If you're going to build your own antenna, everyone puts a lot of hype into, or I call it hype anyway, into the insulation materials, the resistance. If you're trying to build an antenna out of string, it doesn't work, right? It has to be able to conduct the electricity. So if you're building it out of a wire, use copper wire or something like that, something that's going to hold a nice frequency. But you can build an antenna out of anything. For instance, when we grabbed onto the Hack RF, and we actually grabbed onto it, we became part of that signal. Now, scientists have gone through and they actually have this thing called the velocity of propagation on how much energy can pass through an object and what its data loss and all that is. And it's usually measured in a percentage rate. A bare exposed wire is probably closer to 0, while a piece of hardcore plastic with no metal in it is probably like 100%, right? Because it doesn't carry electricity. That said, does anyone know what latex might be? 69%. Next slide. I have to find a way to nicely put that because my kids are in the room. Alright. So these are other just common types of antenna. If you've ever seen these big satellite dishes, these are fun. I used to work up at a site for a 3-letter agency in the alphabet soup, and they, once you went onto the base and went back and over the hill, it would open up into a huge array of these things, and they would point them all over the sky for satellite communications. Really cool stuff. Also, you can cook things on those too. So if you get enough sunlight reflected, you can actually cook things. I don't know. Maybe you're a survivor, a prepper. I don't know. It's a good point.
Did Mythbusters try that?
They tried to create one.
I think they tried to create one off of
Yeah,
one of
they
the
tried to-
home little parabolic dishes.
I think they also use a screen from a reproduction TV.
Yeah. Yeah, there's all kinds of stuff. Yeah, there's all kinds of things. But the big dishes, when you see them, and you're like standing next to them and not just like seeing them on the TV, they're really freaking impressive. But other common ones, slotted USB for broadcast antennas, Batwing literally has like a more of a bow type shape. Whip antennas. Whip antenna is just a huge spike. That's all it is. It's just a core that goes straight up. There's the rototiller. I used to have that picture here. That thing looks like this. I have really no idea how to describe it. It's just a giant coil that looks like something from a steampunk movie or something. I don't know. Helical, parabolic dishes, Yagi, dipole, collier. So a dipole antenna is, instead of one whip antenna, it's actually two. Most of your laptops and hardware electronics are dipole. It has two wires that run up. Collier is just an antenna stack. Straight. It's more like whip antenna. Clover leaf, bike rod panels. These ones here. Anyone walk through a building at work and seen those? Those are, if you've gone through a campus, university, most clients that I walk through have some version of those tucked into the ceiling, or they just have the Cisco router just right there. This is a nice, pretty way to do it as an access point, but that's a different access point. Down here in the bottom right, you can make your own just by stringing up a wire. There's competitions every year for who can it's called like field day or something like that. But amateur radio enthusiasts will try to connect to like as many people as they possibly can all around the world in this short amount of time. And well, you gotta have an antenna for that that'll reach great distances. So they'll literally just put a string, tie the string to a balloon, and it'll take the antenna all the way up. I shouldn't say string, but it'll take a wire all the way up, and it'll just send it up hundreds of feet, and they'll use that for broadcasting. So you can make an antenna out of just damn near anything. As long as it'll hold electricity, it'll work real well. Okay, so antenna size, some size does make a difference. This is the one time where there is no dispute and size does matter. So antenna size are based on the wavelength. There's actually a mathematical calculation for that. Towers can be full, half, quarter, or another fraction of the size. What I mean by that is, if you have a signal of a certain size, whatever frequency you're listening to, you can either have it at a full size, which is the antenna that's needed to create the full size of the wave. Remember, a slow or low wave that's operating in like the ELF range is going to be as tall as a building in New York. Good luck trying to get an antenna that big. Not going to happen. So if we had to cut it in half or quarters, even down to a 64th, you can still kind of try and tune into exact frequencies by creating fractions of the sizes of antennas. Generally, if you see FM and AM AM broadcasting stations, usually they're by water sources, so it can actually have a huge grounding point, and those antennas are massive. You're talking like 200-300 feet in the air. But if we actually tried to measure out the size of the antenna, FM radio wave, so the FM radio wave at 95.3, one of my local stations, the wavelength, again, the speed of light divided by the frequency, is 3.14 meters or 10.3 feet. Well, that looks, if we were to take a fraction of that, say a third, kind of looks like the antenna in a car, doesn't it? It's really not that different. A lot of times what they do is they actually strengthen it by cutting it down to 3 feet and then wrapping a coil around it, which is the same as extending it out to that 10-foot length. So a lot of newer cars will have an antenna that's, like this big. But if you take a look at it, it's, it's like an inch around. It's got an inch diameter on it. Well, they've just taken that coil and they've just got the town spinning it up inside. That's all it is. But it actually equates, there's a mathematical function to equate that out to 10.3 feet. And that's what they generally try to do. AM radio. So on this other side of the spectrum, the wavelength for 1600 megahertz, which is generally if you're driving down the road, it says like, hey, if this is flashing, tune your radio to 1600 something or other. The station for that, the full size antenna is supposed to be 613 feet. I'm not gonna build an antenna that damn high. No way. So one of the things that they do is they start taking fractions of it, and they actually include it into the size of the tower. So this picture in particular, they would actually calculate all 4 of the legs and how they're all tied together to make that mathematical formula. I could not actually go into the math that goes into that. Those guys are absolutely genius and insane. Wireless LAN channel 6 operates at 2.437 gigahertz. If you look at the wavelength, so the actual wavelength side is 0.1299 meters or 5.12 inches. When you're looking at your little SOHO routers, how big is the antenna? About 5-6 inches, isn't it? It's perfectly tuned into the center frequency, so it's going to give that range, right? But that's exactly why they're there. Okay, I am done talking. For the love of God, thank God, I am done talking. All right, we're going to talk about finding signals of interest. If you're, so I do a lot of IoT work, and in doing that IoT work, we get a lot of stuff that comes out with different radio sets. Maybe it's Bluetooth, maybe it's wireless LAN, but there's, or maybe it's like a power meter where it has some type of other radio control that sends, broadcast data back and forth. What I'd like to do is we have access to the internet here, so I'd actually like to go to fccid.io in a browser. So we'll go ahead and open that up, and we're going to look for these FCC ID numbers. If you've got a paper and a pen or a phone, if you want to just take a quick picture so you can see that. Or I'm going to walk through it on the screen anyway. Okay, so why don't you go back to this? Runway! Runway! Alright, now you guys are a little bit braver than I am if you're going to get on that network. I'm actually going to turn on my thing. How's it going, boss? Come on. What's going on? Aha, connected to my handy dandy trusted network. There it goes. Okay, alright, so let's go take a look at this FCC ID number. And I hope you guys get a kick out of this. One of the things why I wanted to, it seems so rudimentary to go to have a lab to go take a look at documentation. But one of the things that I really wanted to make a point here was every device, before it can actually be manufactured, if it's going to transmit, has to have an FCC ID number, which means it's already been through rigorous testing. It's already been, it's already gone through testing. It's well documented already. So let's go out to FCCID.io. And all we have to do here is search for the FCC ID number. If you look on the back of your key fob or something like that, it'll say FCC ID and then it has a number to it. They come in all different numbers, shapes, and sizes. But some of these devices are not actually available yet. So if you wanted to see what they're going to do, or if you wanted to see what's coming out, what's coming down the line, because the manufacturer hasn't actually made this device yet, it's still in development, we can start taking a look at things. So here we've got Wick Far East Limited. It's a coffee maker. And there's the ID number of the coffee maker. So, this coffee maker, I think they just posted these documents up on the 14th. So you're probably not even going to be able to find this, you're probably not even going to be able to find this coffee maker out anywhere yet. A lot of high-end devices that may be coming down the line, cell phones, pager systems, mobile cordless phones, you can just watch for the companies, and as the documents come through on the companies, you can go see what their next latest greatest project is. And so by the, if you've got something that's there, it may be interesting to you. So frequency ranges. It'll tell you the frequency range right there. So this has a frequency range of 13.56 megahertz, and it also operates at 2.412 to 2.462. So it'll do 802.11x, and it also has this other frequency here. Like I have, you can go figure out what that is. You can go see what is there. One of the things that they also turn in on this is exhibits. So they have all their different types of documentation. If we go into the test report or the RF exposure info, any of these, ID and label location, let's see if I can get one to load. Okay, so it'll tell you where the ID and label are. If the ID is on the board itself underneath, it'll actually show you pictures of the hardware. If we looked up the Amazon Dot or the Echo, those are actually printed on the board. So if we went into this to go see, hey, where's the picture for it, it would actually show you where the chip is, where the picture is, and you don't have to take it apart. You can start identifying what the board is capable of. You can identify if it's, what type of flash chips are on it. And you can identify, what are the frequencies it operates on, or even what it listens on. So, there's a lot of fun stuff that you can do. I just love here that they actually have a category for baby monitor. Let's see. All right, so let's go take a look at that other FCC ID number. Search. Oh, come on. All right. So this was an Acer Incorporated WAG tag. I have no freaking clue what the hell a WAG tag is. I just saw that it was Acer and it was a brand new thing that got posted, so let's try to look for WAG tag. What is a WAG tag? Does anybody know? Pet care? Looks like it's a Pabo? Wag-along? WAG tag? Oh yeah, okay. Pabo expands pet care portfolio with trackers and smart, with Acer. So it looks like Acer made maybe a collar or something for their dog, so you can track your dog via, wirelessly. iPuppy Go. So you could read a little bit more about the project. If we went into the actual documentation, here we've got here's all the frequency. This is one of those that I would absolutely hate to take on as a project. I mean, don't get me wrong, I would love it, but at the same time, I would rip my hair out because look at all these different frequencies it operates on. I mean, I bet you that the developers, when they were building this, decided that they wanted to build, a good solid project or a good solid product that could interface with so many different things, and they didn't have to worry about it. So they built it in to transmit on all the different frequencies. But yeah, we've got basically a dozen starting from 824 megahertz to all the way up to the local wild end. And it looks like 2 of these are Bluetooth. That's a little symbol next to them. I don't know if the other one is though. Oh, it just says regular Wi-Fi. Okay. But we could read more about these particular ranges. We could go into the documentation and see what they're actually for. But let's take a look at the test report. All right. So, yep, here we are. Brand name. There's the model number, the FCC ID number. Standard is classified. It is a spread spectrum transmitter. Means it jumps. Let's see. Generally, there's pictures where everything's operated at. Channels 15. Like, you could really get into the science behind this, but I'm looking for something in particular. Generally, if you go through, there's a screenshot and it'll say exactly what type of signal it is, whether it's FSK, on-off keying, if it's a particular, so operates in the GSM band. There's some particular channels. And so if I was actually doing this, I could actually see this. So number of hopping channel plot on channels 0 to 78, you can see it really does jump a lot of channels. Yeah, I mean the documentation is rather extensive. If I was doing an IoT engagement against this, I would actually go through all of these reports within great detail with a fine-tooth comb. Sometimes they get a little tedious and a little annoying to go through, but this is kind of the way that they are. I'm skipping over Lab 4 because we already recorded signals with UQRX while we were there. There is one other feature that I did forget to mention, so I'm just going to bring it up really quickly. You don't have to follow along for this, but I do want to make a point because someone did bring it up. So if we are recording a signal... Oh, good. I'm glad that this happened. Okay, so you can see that as I went to go record, nothing came up on my screen. I haven't done anything to my equipment. There's actually nothing wrong. It's just that the Hack RF or the SDR will get frozen sometimes, like it won't release and let go. So that reset button, just give it a tap, and then everything works again. Okay, so on the far right hand side, we have the little audio control. Some people said, I can't hear the signal, it's too low. Remember all the volumes that I talked about? You have a volume for gain, you have a volume for intermediate gain, you have a volume for the master level for what you can hear, you have squelch, but you also have gain on the far right hand side, down here on the bottom. This is actually what you can listen to. Let me tune into a signal here, and I'll just show you guys real quick. Demod, wide range. Okay, so you guys can't hear it, even though my volume is all the way up on my computer. Now we can turn it up. I haven't set my filter, it sounds awful, but it's fine. There's also another way to listen to this, and that is over UDP. You can actually stream this out over UDP to any device that wants to pick it up and rebroadcast stuff. So you can set up your SDR in your home and like have it sit on your favorite radio station or scan or do whatever, and then you can pipe it out to different sets of speakers that where you might be operating. I know some people who have out in their like they put all their equipment out in their garage or on in a shack on their property or something, in a tool shed or something, and then they go inside and they just connect to it remotely because it's too cold out there, right? So yeah. Alrighty. Okay, so we are going to talk about manual data extraction. So what I'm going to do here is we're actually going to take a look at a key fob. And we're going to take a look as it broadcasts. Oh, right. My lovely assistant has my keys on her belt. Hey, don't do that. Oh. Alright, thanks. No, I'm going to. Alright, so I've had this car for a very long time. The little sticker that had the FCC ID number is no longer here. So I'm going to tell you guys a little secret. With a lot of handheld devices, a lot of push buttons, a lot of just simple on and off or little keying signals like key fobs, they either operate at 315 megahertz, and that's in the US and Japan, I think. Otherwise, they operate generally at 433.92 megahertz. And that's actually before 33, pretty much anything megahertz. There is a standard for it, but there's some variance in it. So in this case, my key fob actually operates at 315. So let's go ahead and open up. GQRX. And this is when you will want to follow along. We're going to tune to 315 megahertz. And remember, you can just type it in if you want to. Alright. I am going to set my receiver option on the far right hand side. I'm going to turn I'm going to turn my DC spike back on. It's a good reference for me. I like to set my receiver to 250, and then we'll go ahead and change the actual frequency. So 315. All right. I'm going to zoom. You don't have to zoom in on yours, but let's go ahead. I'm going to zoom in on mine just so you guys can get a better picture on the screen here. Okay. All right. Oh, actually, before I begin, you see all these little spikes across the bottom? My gain's too high. So if you get that series of spikes where they're pretty uniform all the way across, it's because your gain is too high. So I'm going to go to my input controls and turn down my gain.
Incoming call. I put it on the screen.
Nice. Alright, so. Hey, look at that.
Yeah.
That's my car.
I'm at a conference.
Now, if anyone's recording, if my car is old enough, you could go just, well, now you can unlock my car. That's locked. There's probably going nuts on the parking lot if you can hit it. Yeah, probably not. Did someone else just hit theirs?
Yeah.
Yeah? No,
Mine's
hit
on the
yours.
same frequency.
Huh?
Mine must be on the same frequency.
It is. Could you hit yours real quick? Because yours came up with a different type of signal. It's kind of neat to see. Okay, so if you looked at his just came up with a giant spike, right? That's really cool to see. Mine comes up as 2 spikes. So just because they're the same technology doesn't mean that they're identical. Right, so his came up as probably, if we went to go take a look at it, is probably on-off keying, which is just an amplitude modulated signal, versus mine, which is obviously shifting back and forth between the two, and it's a frequency shift and modulation, or FSK signal. And other people are playing with their keys now like crazy. Good, yay!
Yeah.
Now I'm going to go get in all your cars. Actually, that's not true, and we're going to talk about why that's not true.
That's why I'm hitting the lock button and not the unlock.
So, actually, you know, while I'm here, I'm going to add a bookmark for my car. There. Now, if I ever needed to come back to my signal for any reason, now I know that my car operates at that frequency right there. Okay. We're going to do manual data analysis. So what we're going to do is we're actually going to record that signal. So let's go into receiver options, and we're going to set it for AM. We're going to change our... Hey, don't do that. No, don't do that. You wreck thing. 315. I'm going to set my filter to wide. And then if I get closer into the filter here, I can pull it out. So because I have control of the device, I can actually get a better, I can get a better chance of trying to play with my filter and get my filter on there the way that I want. It looks like I'm actually not at 315. It looks like I'm just a little off from 315. But I think, let's see if we just move over here. It looks like so by the time we get done with interference, the actual hardware and everything else, it may say it operates on 315, but it actually came out to 315.10. Yeah, not inside my filter. So,
where were you looking that you knew it was off?
Huh?
Where were you looking that you knew it was off? It wasn't at 315 on the mark?
Right, so your filter is actually even on both sides of that red line. So if I keep tapping this, actually I can see that I'm outside my filter range right here. Gotcha. Let's see. So I'm going to try to recenter that. Okay. So that annoying sound that you guys keep hearing is me. That's what my key sounds like. Do you want to? Someone else want to take off or pop off their key real quick? See if it's different. See, so sometimes the sounds are a little different. They're fine.
What car do you have?
Huh?
What kind of car?
I have a Hyundai Elantra. Right. Okay. So for this, let's go ahead and hit that record button, and then I'm actually gonna record this out a few times. So, recording in 3, 2, 1. I'm going to give you guys the lock code. Alright. So if we wanted to... Oh, darn it. I'm overwriting. Hold on. Let's try that again. 2, 3. That's good enough. So if I wanted to replay it, it'll actually replay the last thing that you recorded. But you can see down on the spectrum, nothing's here. It's just replaying the audio piece. So, if we wanted to go take a look at this manually, we can do that. So, we don't need QRX anymore, so let's go ahead and close that down. And we're going to open up Audacity. So, sudo Audacity. We'll bring up Audacity. Audacity is more than just for radio wave analysis. It's like a full-on recording studio. People just use it for taking a look at signals because it's an easy way. It has measurement functions, and you can actually modulate the signal to be better than what you've got and what you recorded. So let's go ahead and open up the file. Should come in under. Just take the newest one that you've got here. 17. Is that it?
1630 would be the newest one.
Yeah, the timing is off. This wants to say it came in at 9 something or other. Oh well, it's got the frequency on here, so here this one. These ones are on the frequency. Let's go ahead and open up one of those. You can modify the signal if you want. You can make a save of it, and that's fine. So that's what the actual signal of mine looks like. It's not easy to zoom in on. We actually just have to zoom in on it. Let's see. So this, if you have a mouse, it's a lot easier to play with this. If you don't have a mouse, this really kind of, this is actually a lesson in futility. I'm not actually showing anything about Audacity. I'm just trying to show that there's going to be a lot easier ways to get ones and zeros out of here. But what does your signal actually look like? So, let me get this plugged in real quick. Okay, now that I've got the mouse. Hey, come on, zoom in. Alright. So that one was actually not the signal that we wanted. This was just the dead air one. Yeah, just the dead air. Okay. Let's try one of the other ones. did not get a good signal capture, did I? Okay. So it's actually very hard to see, but because mine is frequency shift modulated, it's a really bad capture, that's all. But as we zoom in, we can see it just looks nasty. It's just the way it is. If we had recorded the signal, my other car actually happens to be an on-off keying signal. And so when you actually go to take a look at it, would you mind would you mind just pressing the lock button and we'll take a quick record and then we can take a look at what an amplitude modulated signal looks like?
Yeah.
Cool. I really appreciate that. Thank you. Let's see. So let me exit this. Let's see. All right. GQRX. Let's see. Oh, great. Yeah. Come on. Okay, give me 2 seconds. Okay, go ahead and hit it. Just hit it a couple times. Okay, alright, that's probably good. Stop. I thought that I didn't close that desk, did I? Apparently I closed that desk. That's much better. So if we went to actually zoom in on this, we can actually see it's still not a great copy. But we can see here that looks like a preamble where it's shifting 1 1 0 1 0 1 0 1 0 1 0, or in this case on off, and you can see all the peaks and valleys. The preamble is set there for a sync. It can be also dual purpose as a wake up call. A lot of cars now also have a wake up signal that goes out on 125 kilohertz. But in the case, those right there, those look like just a series of ones and zeros before it actually gets into a signal. Now we could zoom in on this and we could actually figure out by hand, okay, this is a 1 0 1 0 1 0 1 0. But that is really, really lame. It's very time consuming. However, if you get the timing right, it's really very accurate. That would be the only reason that I would possibly do this. If nothing else is working for you, new radio companion has a way to bust out into ones and zeros, and we're going to play with the Universal Radio Hacker, which will do it automatically for you as well. So you do not have to do this by hand. If you've ever had to do this by hand, you know how much it sucks on a royal level. So we are going to, instead of actually writing out ones and zeros, we're actually going to take this into a different program and use it to process it. Okay. So we're going to go on break for 15 minutes. So everyone get up and stretch. And then when we come back, we're going to talk about what those different types of modulation are. Obviously, when we took a look at my key fob, we saw that there was, it was frequency shift keyed with the little bat ears. They went up with 2 spikes, and now it just looks like a crazy wave. But then when we looked at the other gentleman over here, his was on-off keying. We could actually follow the wave to follow the ones and zeros. So we're going to talk about the different modulations and stuff when we come back and what we're actually looking at before we go into Universal Radio Hacker and start playing with the actual signal and trying to get data out of the signal and start to talk about the ones and zeros. Yeah, so let's come back at, let's say 450. 12 minutes from now. Thank you very much for that. So thank you so much, Trevor. I'm curious. No, and that's the purpose of class. That's why we're here, right? Let's do that. Thank you. Bourbon. I don't know what it is actually, but in bourbons, I do that. It's black, extra aged, and so I asked for a drink. That's what they brought. I'm happy. Thank you very much. I tried to drink this call, but I had a more first time, and I'll try to. Yeah, I'm really sorry. Appreciate it. Yeah. Yes. GQR SDR Sharp is a lot nicer. There's a lot more features to it, so you can get a better player capture. And if you're using SDR Sharp, you can, on Windows, it'll actually allow you to use other programs like PWD, or PDW. PDW has different types of emulators. So you can actually be like, oh, hey, here's a pager network, and you just go push the terminal, it'll interface with it, and it'll start demodulating your traffic. So yeah, I like SDR Sharp a lot better, but it is on it.
So I've never been into this space. It's kind of why I've been.
Oh, you got to go get an SDR.
I was looking on Amazon.
Yeah, that's right.
There's a bunch of other Black Friday, okay. Next week, right? So they come down. I think it was actually a really good blog. I could see a couple guys blogs.
Yeah, really good place to start is Tech 5 video series.
Yeah.
I think last year she actually made a side channel. So you actually go, not just YouTube and if you go to the actual page for Act 5, one of the playlists is all of their SDR work.
Okay.
Mike Osmond, if you have a Mac RF, Mike Osmond has a great walkthrough for that.
Sure.
Radio homepage that was up on the ISO that I did. That homepage, or I think it's just www.radio.org. It actually has guided walkthroughs and tutorials on how to have this. Yeah.
Are you sure? I'm about to lose juice.
But yeah, there's a lot of stuff.
Yeah, there's really one thing talking about GQRX and he does
yeah.
software. I'm like, oh, yeah, it's bad. Gotta figure all this out. So then there's other things like
that mouse for like 4 years.
geolocation and stuff.
Oh yeah, there's we are not even beginning to scratch the surface of this. And there's all kinds of stuff. Once you really get into this, when you realize how many things that you have in your house actually have.
So that's what the Conclave. I just bought this when I came down here. I'm ready to sit in Pennsylvania. So it's 3.5 hours down to really talk about this.
I appreciate it. I drove 6 hours to be here.
I have a weather station that's been sitting in the package for 2 years. And it's pretty much you put a Wi-Fi dongle outside, and it reports back to the station all the weather. And that's really cool. No one started this thing when
Exactly.
wireless, you know.
Exactly.
It's just in a box.
The plug that we're going to test is just a power switch, and we're going to do a replay attack against it here in the class. And so when we do that, it actually this is from Chicago Wire, which is like hardware pretty tools. Like the cheapest of cheap. I literally sat there doing where I was working on another project on my own, and I came across and said, hey, Do you have any pictures for some of the wireless stuff you're doing? We've got a client coming up that they want to see some stuff. No, but also I had it. If you did ID card that has wire attachment, I sat there and documented them all. I was going through it. Hey guys, that's what you can change for hardware.
So for reference, you were still on the research side of things?
They had ID cards.
No, I was I do everything, internal, externals, web applications, wireless, mobile devices, RF, IoT. IoT is one of my big ones, because there's only so many people on the team that can do IoT. But I just took apart two. He was.
Or I do want to
I used to teach the classes.
I'm rewriting some initial thing and I for it.
Yes.
And I told them like several times already. And they're like, oh, I'm running a new one. I rewrote it all. I'm a PowerShell guy. I rewrote everything in PowerShell. I just had to straighten it out.
I understand.
Yeah, no, I mean, it's another guy working with too. He should help in the writing too. But we do a lot of scripting with it. There's a lot of data needs up within the database.
Yes.
That
Yeah, I do a lot of. I'll go to the interface and I have scripts that built in SQL. So not having to deal with the API, but nothing, just doing live SQL just to get the data out. And a lot of times I go to their sites and it's been years since I've had to do that. They're like, okay, you can do this with it, you can do that with it, you can do oh, you guys can see value very cheap on yeah, here are my scripts, just throw them in. All that data is so valuable.
the thing about rewriters too, the tool itself, you know, other people kind of about this. You can't focus on anything too much. You can't. So there's a whole bunch of process, like I said, some macros going on. And I'm like, I pull data out and put it right back in. And I'm like, I shouldn't have to do that. And I'm like, well, how long is it going to take me? Well, how many assets we're doing this for? You know, right now, fucking 3 months you don't have to do it. I work for a university.
University hospital.
Some of the ones, which are my manager was but we all let it out of there. You know, put in this in, and like, oh, what do you got? Okay. API wise, and you can pull data out. Every data warehouse. I finished setting that up a couple weeks ago.
Have they talked to you about Insight?
Yeah.
And all the different reporting?
The issue I have with that is I need to wait for street on Amazon.com.
Oh, wow.
I'm not driving that one, and I got told, hey, you can also proxy that. Either for a firewall or so if you pay proxy for that, it's not do that.
That'll be way too yeah.
So we do have like the personal dashboard. But the data that's out there, generally, under the phone, the data is not accurate because the whitelist. So there's like there's 5 sites you can whitelist, 4 of the 5 and there's plenty to get to. There's 3 of them. I get on.
I've fought with producing lawyers for maybe 4 hours doing this. I understand it's
I mean, I'm very good with it. I got up there at CSM and I'm pretty sure it's so do you work remote mostly, or you work remote, or are you mostly go to the office?
No, I wasn't. I definitely very happy to live in SDR. Yeah, especially since like Austin used to be on the outskirts of Austin, and now we have a building that's downtown. They just created 5 floors and one of the buildings near after that. Just like so all of our developers used to live like an hour outside of that. Now they have to go all the way down to the downtown office. And before we were not allowed usually those guys to be remote. So that's what we're trying to promote, right? So all of a sudden, like, we have the
whose bright idea was this? So they finally started watching me. But I love coming down to the bus stop and the other dad was there on PG. It's work. Get ready to drive these tracks.
Do you have a blog or anything? Or?
It's currently on my own. But I was putting my blog stuff with us on driving down the school. I think the last blog that I did was what the car bench. So we had to take out the car and turn it into a workbench. That was awesome.
I think it's on the conference.
Yeah, they had a little brochure. I never saw the brochure. I know that was there, but I never saw it.
Yeah, it was there. It was pretty cool.
Oh, did someone actually had a bench? Oh, that would have been great bench. Yeah, it's less than nice than mine. Mine was ugly as things. It's ways naive. What was I going to say?
How are we doing on time here? Okay, they got 1 minute. I don't know about these breaks. I keep losing students here. Not losing. You guys aren't going to sleep on me, but you're leaving.
It's getting later in the day for most people.
It is. And this class is, it's 4 hours long, too. The one gentleman I know who's having lots of hardware issues, I think he just mentally gave up. One of the other guys, I think he wanted to go to another talk that was going on. Alright, well, it is time and we've got to get going, so. Alright, so when we were actually taking a look at the signals, we did see that there was an FSK signal, or the 2 ears, and we saw that there was an amplitude modulated signal, or on-off keying. We were able to go in and take a look at those. But those are just the tip of the iceberg. These are some really common ones. But they basically, most signals fall into 2 different types of categories. Either they have a carrier wave. The carrier wave can be suppressed, so if you don't see the carrier wave, don't feel alarmed. But basically, it's digital or analog. So carrier wave or pulse modulation. Even pulse modulation can have an analog piece to it. But the carrier wave you're going to mostly see in the RF. Pulse modulation you're going to see like on chips for IoT and cars, like if you have a Hall sensor on a vehicle, something that's maybe registering the number of turns, the revolutions of the crankshaft position or something, it's a Hall effect sensor, and it's going to be in pulse modulation. But it's not really a wireless signal, it's just how the signal actually gets there. Most commonly, we're going to see amplitude modulation, we're going to see on-off keying. On-off keying is like Morse code, literally like a light switch, turn it on, turn it off, turn it on, turn it off. It has set defined patterns of time, but it's really easy. You can sit there and listen to it. You can even pick out the ones and zeros. When we start shifting that the wave, so we start changing that 360-degree pattern that it initially has, we start changing the oscillations of it. We go into frequency modulation. The frequency modulation we're going to take a look at in a little bit better light. Just know that it's not actually turning it on and off. It's keeping it at the same. It's keeping it at the same, or it's actually keeping transmitting. It's just changing how fast it oscillates the signal. So it actually jumps from one frequency to another frequency. And this is easier explained in a picture that's coming up. So just bear with me here. But I'm not going to go over all of these, but some of these are really kind of cool. When you get into frequency shift keying, you don't just have to shift between one frequency to another, you can actually do multiples. When you get into code division multiple access and time division multiple access, you're talking about cellular companies. So especially with time division, if you've got time division on frequency shifting, and then it's got spread spectrum techniques and all this other stuff, then it's usually encrypted. On top of that, signals get really complex really quickly. But you still have a lot of fun going through the multiple layers. You just got to be aware of what those can be. Phase shift modulation. Phase shift modulation it actually changes that full-on wave. I'm gonna show you what that looks like in a picture, but it can use the shifting of the signal. So instead of sending one full wavelength, it can actually stop at any given point along that wavelength and reverse direction. When it does that, we can actually do that in certain ways, and we can change exactly where it along that wavelength it actually is modified. When it's modified in that capacity, if we do just two shifts, we've got phase shifting or biphase shifting into two. We can use it to send, instead of 1 and a 0, we can send 2 bits, a 1 and a 0, or 1 and a 0. When we get into quadrature phase shifting, we can actually send 2 bits for 4 times it shifts. So we can actually send 0, 0, 0, 1, 1, 0, 1, 1. So we can actually use the same signal to send more and more and more data. Once you get above 4 PSK or 2 PSK, you get into QAM, which is quadrature amplitude modulation. Quadrature amplitude modulation is basically saying 8 QPSK. And this goes all the way up to 4096 QAM. TV broadcast stations, like satellite TV, use that. So imagine 4096 points along this wavelength that you can shift data. And it'll send 4096 bits of data. That's like HDTV, but being sent across multiple channels all at the same time across the satellite, right? Because every time it hits a different point and marker, it can send 4096 bits of data. And then as it oscillates all the way through the signal, I mean, it just can send so much data so fast. So they're the ones that really use it on that high level. But manufacturers like little key fobs, on-off switches, things like that, little home consumer electronics, you're gonna see probably BPSK or QPSK. Really simple, much more simple signals. Here's a better up-close shot of amplitude modulation. You can see here at the 0 reference point, we actually have, this is just the baseband here, this is the noise, and as the signal goes on, here's a 1, 0, 0, 1, 1, 0, 0, 1, 0, 1, 1. You could actually map that out based on the smallest measurement of this. So actually this is probably 1, 1, 0, 0, 0, 0, 0, 1, 1, 1, 1, 0. You can measure it out. We're going to find a much easier way to do that. The signal, when you're looking at it on the spectrum analyzer, just looks like a giant spike. But you can usually hear, it doesn't sound like just a tone. It doesn't, you can actually hear it change in cycle through bits. Morse code is the most common form of on-off keying, or digital signals. The reason for this, why you're going to see it so often with IoT gear, is because it's cheap and easy to implement. A lot of garage door openers, car door openers, anything that's really basic, where they just mass produce them, they just wanted to get it out into the market, especially third-party knockoffs for a lot of devices. Is a cheap and easy way to get your signal out there is just to send a series of 1s and 0s with amplitude modulation. Okay, so FSK on the left-hand side there. On the right-hand side, we have an MFSK or 4FSK in this case. But remember how I said it actually just takes the signal and it changes or shifts the frequency. If we look here, we've got, down on the bottom, we've got a condensed number of sine waves where the frequency is actually going faster. So this is a higher frequency, and then all of a sudden it goes into a low frequency for a time period, and then it goes back up into a high frequency. So we can assume that this is sending a 1001 pattern, if that was to continue on. So in this case, that 1 was probably up here, where it's sending at a higher frequency. So it would be transmit here for a period of time, transmit here for a period of time, second period of time, transfer back. And so it's literally just shaking that signal and making it go faster every time it needs to send a 1. That's all it's doing, or it's holding it at that speed. In the case of MFSK, it can do the same thing, but it can send, instead of sending a 0 to 1, it'll send 0, 0, 0, 1, 1, 0, 1, 1, or a combination of however they change that. You can really spread that across the spectrum and get a lot more spikes out of it, get a lot more data transfer. However, the more you do that, the more expensive it is. So a lot of consumer electronics, are going to be the simple FSK. Just kind of like my key fob was for my car, right? In the field, we commonly refer to these as bat ears. In a perfect world, it literally does kind of go up and make a nice little U and then come back down. We used to call it the Batman signal. However, it's not always picture perfect. So, I mean, you can see here, it actually looks like two grounded signals, and it just looks ugly. This is actually zoomed in quite a bit. If you have a low powered signal that's transmitting at a high frequency, so something that's really short range but high frequency, because of the accuracy of it, because you have to be so close to that device, you can actually get it to shift frequencies just a hair, just a little bit, maybe just a few hertz. So when you look at it on the spectrum, it may actually look like on-off keying, or it may actually look like frequency shift keying. Like you have to really like zoom in and take a look at it. Clear as day when I hit my key fob, there's an actual separation there, so you can see the two frequencies really well. There is a term for that. I'm going to kick myself, and I will probably remember like 2 o'clock in the morning. It's just like I would close my eyes. This term, and I am really going to kick myself for it. Anyway, and so FSK doesn't have to just be two frequencies. It can be as many as it wants to. Let's see. All right, phase shift keying. All right, so this one takes a little bit more to explain, but basically, let's say that we have a digital signal here. Okay, so here's our modulated signal, our square wave. Okay, so we have 1 0 1 1 0 1 0, and the modulated wave looks something like this. When we stop playing on our cell phones. When we actually introduce the carrier wave, which is going to start to transmit the signal on the frequency that we want, right? Because it's going to control the frequency. We end up with, every time it changes from 1 to 0, we actually get these little divots, right? You can see where it's stopping midpoint, turning, and changing the frequency, changing the actual angle of the wave. So if we were to take a look at 4PSK or QTSK, there's actually 4 points along this whole entire wavelength where this could change. So it would be at the 0, the 90, the 180, and 270. In that case, because we have 4 points, we can send 2 bits of data. If we double that, we'd have an 8 PSK or QAM, and we can send, because we have 8 points, we can send 3 bits of data. And you can see the different ways it would shift. Remember I said everything operates in 360 degrees when we're measuring out radio waves? This is one of those things we have to really pay attention to that, because no matter how many times you look at it on a spectrum analyzer, or you see it in a textbook or a picture of it, it's always 2-dimensional. But when it actually transmits, it's a 3-dimensional object, and it has shape and volume and goes out. So, I mean, you can put yourself in a mental hospital going through all the physics of this. Radio waves, I mean, when we talk about radio waves, you can actually start out with the smallest atom and talking about moving that atom and just oscillating it through the air. But as you get faster and faster with frequencies, and you start talking about really advanced complex signaling in that, you can actually talk about the Boson-Higgs particle and explaining the universe and the theory of relativity. I mean, like, you can really go out on a limb. When I was first starting to build this course, ask my wife, I spent like multiple nights just engorged in math. And I went to bed very happy, but could not speak because my brain was just like fried jello. It didn't work out so well. I retained most of it, but like I started playing mathematic games and stuff. I just started going and having so much fun with it. You can really have a wonderful time with it, or you can make yourself go stupid. Alright, I step off my nice soapbox now. Alright, so this is 16 QAM. So in the case of 16 QAM, you can see we have 16 points. So we've actually shifted that signal 16 times. So what you're seeing here is what they call a scatter plot, and so somewhere along this signal, this big, huge download signal, it really does kind of look like this, and usually the wider it is, the more data points there are, unless it's slow, unless it's farther down the spectrum. There's some general rules of thumb. But for the most part, the wider it is, the more data points there are on it, because going across this top is actually changing that signal frequency. To get a nice, pretty plot like this, you're talking about recording plots for, a good 10 minutes, like on a 10-minute signal, to see all 16 of these plots. But they all have a particular, in this case, power and angle of the signal. So this is sending at full strength, at 0 difference in the angle. This is maybe at half strength for 0. This is let's see, 90, but in half, and 180 and half. Yeah, so it gets really complicated really fast. But QAM signaling technology is, this is what we use for modems. For, if you grew up in the 80s to 90s, when you would hear your modem start up, if you actually looked at that on the spectrum analyzer, you can actually go download the signals and bring it for nostalgia. Or put it on your phone as your ringtone, I don't care. But if you were actually taking a look at it under a scatter plot, you could see all the different points in the QAM where it's actually syncing up all those bits. It's really neat. Alright, now I'm going to get off the soapbox and we're going to actually have some fun. So with the last labs that we had, we went through and we had manual data analysis. Looking at that wave, we saw the amplitude modulated carrier, or the signal from someone's key fob, and we could see the ones and zeros going through. Instead of actually having to write them out, we're going to use Universal Radio Hacker, and we're going to examine those ones and zeros that are on there. After that, we have this Chicago Electric Wireless. This is the Harbor Freight brand. And we're going to do a replay attack against this to control light. Now, my guess is if we had a regular light bulb, I wanted to see, if we had this many people transmitting the signal into class, if we could get it to flicker fast enough to destroy the light. That's my thought. But we're going to see as it goes. Alrighty. Okay, Universal Radio Hacker. Alright, so to bring up Universal Radio Hacker, let's see, sudo URH, Universal Radio Hacker. Okay, alright, so it should just open up and you shouldn't see anything right off the bat. What we're going to do is we're actually going to take a look at the spectrum analyzer that's offered by Universal Radio Hacker. Before I begin, it's going to happen to you at least once in the next 10 minutes. And even if you're at home using this on bare metal box that you've installed, once it grabs onto a signal, if it gets any type of hiccup in any way, shape, or form, it doesn't want to let go of the hardware. So you will constantly have to be loading and and closing out the program and then launching it again, resetting the device. But hopefully it'll, the demo gods will let us play nice. So let's go into the spectrum analyzer for some file spectrum analyzer. Or choose your device. In this case, I've got the Hack RF. And I'm going to set this at 433.92 megahertz. Remember, I said that was a really common frequency for consumer electronics. So what are we going to do? All right, so I've set my gain at 1424.32, but you can play with it on your own. If you're using the Hack RF, set your sample rate to it should already be set to 2 million or 2.000. If you're using an RTL SDR, there should be a drop down for you, and I believe it sets it at 1 million or 1.8. I can't remember. All right, so when you're ready, just go ahead and hit start, and it should bring up a rudimentary spectrum analyzer. So we can see here there's really not a whole lot that we can do with the spectrum analyzer. We can change its position a little bit. We can play with the gain and take it down a bit. We've got a frequency hold. If you can zoom in, zoom out, that's pretty much it. It's really rudimentary, so definitely not what you would get out of GQRX or SDR Sharp on Windows. But let's go ahead and give it a signal. There it is. Okay, so does anyone remember what all those little spikes are? What it means? Gains too high. Gains too high. So let's turn that gain way down. Okay. Reset. Much better. much better. Okay. Alright, so we can see in here as we transmit a signal, it comes up. But from here we can't really do anything to record. So let's go ahead and close that out. Come on. Alrighty. So now we're going to go back in. So this time, we're actually going to record a signal. Okay. I'm going to choose my Hack RF again. I'm going to set my frequency. It should be 2. And the reason why I know it's also at 433.92 is the FCC ID number. If we went to go look it up, it's right here on the back, NS3425T. So we could go look that up and pull exactly what frequency this is sending on. Okay, so I'm going to go ahead and record. And I'm just going to, so if you guys are recording, okay, alright, so mine in this case, if you can see it, obviously it's not showing anything. Not showing anything. So my hardware is locked. So what we have to do is just close out the program and relaunch after we hit the reset button. So I'm going to close, I'm going to hit my reset button, and I'll bring it back up. File, we're going to go into record signal, set the Hack RF. Okay, and what did we have this? I think we had it at 8 and 4. I'm going to go with 8 and 8. That's fine. Okay. Alright, so as we get ready to record, so if you guys want to record, I'm going to hit record in 3, 2, 1. Record. And you can see it going across in the signal there. Oh, come on. Don't give me that. There it goes. And we're just going to give it a few more clicks here. Okay, and we'll go ahead and stop. Okay. So let's go ahead and we're going to save this. So just go ahead and save it anywhere in your SDR folder. In this case, it's going to give you the frequency, tell you what the sample was, and it's going to save it as a complex signal. Because it's saving it as a complex signal, we can take this into a more advanced digital signal processor like Mu Radio. We can take it into GRC and actually go to town playing with the ones and bits and playing with modulation or retransmit or anything like that. So, okay, so I'm just going to save this here, and we're going to close out of the record signal. So, as you have the application open and you are and you're recording, it's going to immediately jump you over to interpretation. The interpreter is actually going to go through and try to figure out where the ones and zeros are. It does have this nice pink fuzzy little thing right here. Okay, maybe we shouldn't call it a fuzzy, but if you wanted to zoom in on some of those, you can actually see where the ones and zeros are. But that pink line is actually where it's determined the noise level is. So we're actually going to need to turn the noise level down 0.025, perhaps. No. Don't give me that. Stop. Mine froze. There it goes. Okay, mine decided to lock up on me. 0.02. Let's see what 0.02 looks like. Come on. Now, if you're operating on bare metal, this goes pretty quick. But considering we're in the VM environment, this is not as quick as we'd like it to be. Okay, so now you see we've got a little bit more, a little less than the filter there, right? So we can actually see a lot more of the ones and zeros that are here. Come on. Scroll. Come on. Oh, demo gods, what have I done to piss thee off? Not coolio. I tell you what, while that tries to come back to life, this poor Frankenstein in the box, I'm actually going to set up the light. So, what I have here is the other end of this switch, which is just a power plug. And so this was meant like you could set up your like you could set up in maybe a workshop or something, a remote light switch. So you can turn it on or off. And I'm just going to leave this in position. Let's see. So if I was to actually turn the light switch on, there it is. Okay. So very bright light there. Right. Yeah, so as we hit the on button, as we hit the off button, on, off, that's all we did was record that signal. Of course, it's junk and sometimes it doesn't like to turn off. Alright, so let's take this signal and we're actually going to replay this signal. So, stop that. Stop. Okay, alright, so up under the complex signal, there are some things I do want to point out here. It's down here in the modulation, you can see it actually came up as FSK. So it tried to auto-select for us what was going on. We're going to take a look at the analysis of some of the generator a little bit later. I'd like to actually go back to the key fob for that because it's a much cleaner signal than this. But so up there in the complex signal, if you had a good recording, go ahead and just hit that play button that's up there on your screen. And let's see how much we can get this thing to blink. So when it comes up, just go ahead and hit play. And we'll see if we can't get it to come on and off. Come on. Come on. Oh, you suck. Okay, so last time I had this problem, it was because there wasn't enough gain. So I'm going to turn my gain up. And we're going to hit it again. If I wanted to just send a part of this, I could actually just highlight it and send it. So I'm going to skip that whole first part where I wasn't sending anything. Come on. Hang on. Hooray for a demo. This actually does work. I have a video of this. It actually does work. For some reason, it just doesn't want to send out right now. Or maybe everyone's sending it on and off. Can everyone hold up for just a half second? I am going to close out of mine, and I'll just try sending it this way. Yes, I want to close. I'm going to walk through it just one more quick time. Is my hardware locked up, and that's why I'm not sending? Yeah. Wait. Let's go record a signal. We are there. Come on. Did anybody else stop working? Mine doesn't even want to go. Hooray for demo guys. This is why it's always awesome to do stuff live.
There you go. I got it for you.
Hey, alright, I see somebody did it, yay! It does work. I'm a liar, I swear to God. Yeah, so it really is that easy to get it to do a replay attack. You can just sit there and record, and if we went through, let me see if I can actually open that file now. There we are. Open. Alright. So if we actually went to play that signal, if we actually wanted to zoom in to see like which one of these was the on, which one of them was the off, we could just sit there and replay like on, off, and see what the actual difference was, or we could compare what a certain on-offs were. We're gonna actually record one other signal using the key fob because it's gonna give us a clearer picture than this thing that just blasts out energy like crazy. The ones and zeros don't really do it any justice when we're going to go in and play with like how to set a preamble and how to fuzz the signal. So let me get my gear. We can take it one more time here. Let's see if we can't get it to go. The other alternative is to reboot the entire VM. But as many problems as a lot of people had trying to get it up, I don't recommend it right now. It may not come back online. Okay, so we're going to go try to record another signal. This time it's going to be at 315 megahertz. I think we said it was at 315.10 megahertz, right? There it goes. And I'm just going to record it. Okay. So is everyone ready to record? Anyone who's recording? Yeah, whoever turned the light off, thanks. Of course it doesn't. Okay, I'm gonna give my VM a reboot real quick. What time is it? We've got 5:30. We still got a half an hour class and about 10 slides to go. So while this reboots, I'm just going to keep talking, and we will see if we can get this back online. All right. Okay, so decoding bits. When we actually get a chance to, we're going to talk about, we're actually going to get to see the ones and zeros. Ones and zeros can be a little hard to see because our brains are actually trying to interpret 1 and 0 as a binary number or maybe a hexadecimal number or something like that. There is actually a program that you can get for. There's a few things. I mean, it's straight up a Linux program, but you can use it in new radio companion. There's a new module for it. It's called Bindner. This is how the Navy trained us to see these instead of ones and zeros, to see them with black and white blocks, because you can clearly. I mean, you can start to see a lot more of what's going on in the signal. And as you start to shift bits back and forth, you can start to tell when the signal starts, when it stops, if there's a preamble, ones and zeros. A preamble is mostly just a sync. That's all it is. It just gets the baud rate set up to make sure that the receiving terminal knows exactly where it's on par, and it can start to receive those ones and zeros, measure out the baud rate, and actually interpret the signal. Just like with telnet or serial line device, we have data, we have start-stop bits, parity checking, we have CRC codes. So you might have data, and then we have data, and then we need a bit that sets whether it's even or odd, and then we have a hard stop bit, and then we have integrity checking with the CRC codes. So maybe there's some mathematical computation that sets like 5 or 10 bits or whatever afterward. You can send data inverted. It's all at the limitation of the imagination of the engineer who actually built the system. On top of inversion, we have encoding. We have Manchester encoding. There's Manchester 1 or 2, and then non-return to 0. Most of the time, you're going to see non-return to 0. I will talk to these in just a half second. And then if you need a graphical version, Bindner is there. Okay, so in the case of key fobs are not some of the older ones. Definitely some of the older ones, maybe like the late 90s when key fobs were just coming out. You could do the same replay attack that we have now, but you're not going to go up to a Ferrari and go catch the Pope or opening up his Lamborghini, and yes, Lamborghini did give the Pope a Lamborghini. Yes. Anyway, so you're not going to get that signal to capture and then just replay it. There's all kinds of tricks that they do try to get in there. We saw that one was OK and one that was OOK and one was FSK. They do these for convenience. So they're not going to put too much money into them. They're not going to put too much technology into them, but they do have to protect that car and their liability. So they've implemented some of these things. Some of them have a wake-up signal that goes anywhere from 120 to 140 kilohertz. This is so you can have multiple fleets of the same card, and there's no two codes that are going to sync up because they're going to have a unique wake-up code. So you may have to capture the wake-up code, and on top of that, capture the code itself. Some of them are near-field communications. So you can actually use your phone to start your car or unlock your car. Those operate at 13 megahertz. The passive keyless entry. Passive keyless entry and near-field communications are somewhat similar. The near-field communication has a different particular chipset. It operates on a different frequency. But the passive keyless entry is the key fobs where you can be in range. You can just be in range, like a Prius. I had a Prius where you could not lock the key in the car because it would detect how far away the key was. So if you were inside the vehicle, you could not. If it was inside the vehicle, you could not lock it if no one was sitting in the driver's seat, which I thought was really great because for many years I was on a first name basis with like tow truck people trying to get my keys out of my car. I'm horrible at it. Also, on top of that, this is their basic schema. So I wanted to take a look at it, and we'll see when it comes back up. Hopefully we'll get a chance to take a look at the bits. There's a preamble, there's data, there's checks, and rolling codes, or another type of security key. Rolling codes means it's not going to send the same key. It's going to send either a 1-up, which is a really bad rolling code, or it's going to change the whole entire signature of the key, and actually send a instead of sending a 1, it's going to send a prime number, or that whatever that signal is times by a prime number. But it knows the proper sequence. Security keys and rolling codes are possibly stored in the memory of the key fobs. So if you're into IoT, if we took apart the actual key, This is the little transponder that actually locks out your immobilizer. So if you have problems with you can actually get these reset at like Home Depot and stuff. You get them when you have custom keys made. If you have an immobilizer, they can actually copy these. I thought that was really weird, but they can't copy the firmware, so it didn't make a whole lot of sense. Like this, the immobilizer is controlled by you, so they can just replace this and just code it to it. But that chip right there, that probably has some kind of memory on it. So if you could actually break into it, maybe it's an SPI flash chip, maybe with a JTAG or a JTAG device like the shipper or something, and pull through debugging, actually pull the firmware off of it. They can be for a good time, but then you can actually guess the rolling code. There's other ways of jamming it, and as people try to hit the button over and over and over, as you're jamming it, you're also recording at the same time. So you can possibly intercept what those rolling codes are and try to figure out what the rolling code is.
Incoming call. I put it on screen.
Sorry.
No, you're good.
Incoming call.
So here's just a basic example of rolling codes in some of those key fobs. Maybe this is the different sets of patterns. Where this whole entire thing is basically send unlock 4 times, and then go to the next set of rolling codes. But you see, none of them are the same. Like, and don't cross eye looking at it. I actually went through this.
I think we got about
no, not the same. But you can see here we've got kind of a sync.
Yeah.
So it has a defined set of bits that actually start the signal. So once you, it's like, hey, computer, or receiver, when you see 0, 1, 1, 1, the next set of bits are all going to be my data, or the next number of bits are going to be my data. And then this bit over here was actually polarity check. So it's actually sending whether it's odd or even. I think this is even. So it's giving a 1 or 0 based on whether there's an even amount of ones that are going across here. And then there's some kind of check which I couldn't figure out when I was like 3 o'clock in the morning, 4 o'clock in the morning when I was looking at it. But that's the basis of a rolling code. So if we actually took a look at this, maybe we could take it out to the hex values and see that, oh, well, it's just sending, this plus 26 bits, or, this plus a prime number, or the next prime number in a sequence up to 2000 something or other, we could take a look and try to do some mathematical analysis on there to guess, or make a pretty good guess of where that next rolling code might be. GNU Radio Companion. I remember I said we were not going to do something with GNU Radio Companion because there are so many resources online for this. But it is a digital signal processor, so it's not just a radio companion. It's meant for processing signals. It's a huge community. As a matter of fact, if you go to DEF CON or one of the bigger conferences and use anything besides GRC, you're gonna, get nerd raged all over. So yeah, it's a huge community, very devout followers. But it means it's also being actively developed very well. There's all kinds of add-ons, even though you have it installed. There's third-party add-ons that you can get from other Git repositories to match certain chipsets or match certain coding types, depending on what you're trying to do. It's also it's all written in Python. So even though you're looking at a nice, pretty GUI, what you're doing is you're actually setting all the values. It's just placeholders. When you actually hit the run button, it compiles it at that time and then executes it in the background for you. So anything you can do with Python, you can do it in GNU Radio Companion, which I really love. To get really deep and dive into that, Mike Osmond has a great series that you can link to from Great Scott Gadget's website. Hack5 did a thing on it. There's all kinds of YouTubes and blogs. Just Google it, you'll go nuts. Okay, we are actually going to skip the new Radio Companion. I had forgotten to edit the slide. We are going to paint pictures in radio waves. This one's fun. This All right, So let's see if my VM came up and see if I can get this back up and running now. Really? 3 letters and I missed it. Come on. Take that. Give me just a second and I'll be up. Glad you're having fun with the light.
I'm gonna break it for you. Let's see how fast we can get this one together.
Well, see, that's what I was hoping. I was hoping everyone would be able to record it and it would, be able to, While you guys get that up and running, or you guys go and have fun with that, I'm gonna. Okay, now that I've got my equipment back up and running. Hooray, that's a 0 day. It's not reported, and I didn't report it either. Go ahead and have fun. They're not going to care. Report it all you want. It's like the guy that reported the weak password, the default password for Backtrack and Kali Linux. Like, really, who cares? Well, actually, I should take that back. We did have a consultant who came in, and we do giant hackathons where my whole entire company comes together and we just have fun breaking stuff. And everyone was on the network, and somebody actually did launch Kali and then change the stupid password. So it happens, I guess. All right, let's record a signal here. I'll get my Hack RF up and running. I'm going to change this to 350. Stop that. 315 megs. Okay, now that I have a signal, let's go ahead and close that. Save. Now let's go take a look at that one, the ones and zeros. Okay, so now in this one you can see that the noise filter actually worked a whole lot better, and it said that it determines that the baseband was in the center there. It's trying to crop it out, and then it's trying to pull the ones and zeros. But that's all the ones and zeros, and we could go and take a look at this. So let's see. So let's go into analysis. And it's already tried to figure out what type of encoding it is. It's determined that it's non-return to 0. In the case of Manchester encoding, it can actually, depending on how it shifts the signal across the frequency, it's the same as using QPS scan. It can actually just send more data bits based upon its shifting capacity. And there's different ways to interpret that. So there's a Manchester 1, 2, and a differential. But if you go into the FCC ID documents, it'll tell you generally if it's using Manchester encoding or what type of encoding it's using, or how or what the chipset is, and then you can go look up the chipset and see what the encoding is. The reason for doing that is a lot of devices, if you don't have the right ones and zeros, you ain't gonna get nothing, right? So in this case, I'm going to delete this. I'm going to hide this first round. So hide selected row, and we can already see some unique things here. We can see we have a string of zeros. We have two ones, 2 zeros, 2 ones, 2 zeros. So this looks like preamble, right? I can tell you pretty much it shouldn't look like that. My gain is too high, so it's actually echoed twice. So the signal's been doubled up. It should be going 1 0 1 0 1 0 1 0. I forgot to adjust my gain, but I'm not gonna play with it right now. So one of the things that we can do is, as we get going in the signal here, we can see where exactly it starts to change that signal. Okay, so there's somewhere where it's starting to change the signal. Across here. So it's in a huge series of ones and zeros, and then now it's changing the signal. So we had preamble, and we probably had some basic data checks in the beginnings, maybe that last 1 and 0, or there's, yeah, it looks like a 0, 1, 0, or 1, 0, 1, 0. Yeah, so there's probably two bits that have been specifically set that say, hey, this is where my data is going to begin. Now we can see it starts to transition into data. One of the things about Universal Radio Hacker is we can actually create labels for all of these things. So as we add labels, it'll change colors, and we can come down here and set the color. So we'll actually mark this as data. This is the, just for giggles, I'm going to put it as, these are control bits. So we're not actually going to go through and break out ones and zeros and figure that out. But let's say that we wanted to take these 4 or these 5 right here, and we wanted to replay the signal. So we've got it down to where we think we know our data is just within, say, a few ones and zeros, a few bits, right? So you could actually, hold on. Come on. Okay, stop. 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 I'm going to take this one as my good one. Copy section. Hey, you're not supposed to do that. Control V. Stop that. Delete. Come on. Paste. Of course it doesn't want to work, right? Copy selection. And paste. Really? Of course it doesn't want to. Alright, so you're supposed to be able to copy and paste into the field, and it's supposed to copy over in your ones and zeros. Using the fuzzing, you can actually choose which exact bits you want to change, and then replay that through the signal. So if you just cycle through 1, 2, 3, 4, 5, 6, 7, 8, 9, you can do that. Mine's just being a pain in the butt at the moment and doesn't want to play nice, so we're going to skip it considering we've got only 20 minutes left in class. I'm really sorry. I will hope to get this put up as a YouTube video down the line. So, I am, sorry. It doesn't want to play nice. The demo guys have not been with me for the last 3.5 hours, so I'm not expecting much out of it. So for this last lab, anyone who has a hack RF, we're going to actually put a picture into the spectrum. So instead of just transmitting the ones and zeros that make the picture, we're actually going to transmit, we're actually going to make the ones and zeros as we see on the waterfall display or the FFT display, actually display the picture. So we're actually going to write a picture into the spectrum. I just need a half second to, I have to disconnect the screen for just a half second because I have to go and set up something on my machine. And it's going to expose the file. So give me just a half second here. Okay, so this is the last lab, and then there's a little bit of just general warnings: what's legal, what's not legal. Not that really make us a lot of us really stop what we're doing in here, but The big thing, I mean, the biggest number one rule is don't be a dick. I mean, that's really it. If you're screwing with someone else's signal, that's where the bad things happen. And don't screw with law enforcement, for the love of God, don't do it. You can go to jail. Okay, I'm almost ready. Yeah, there we are. Okay. All right. So I'm actually not going to put this up on the screen. What I'm actually going to do is give you guys the commands that are necessary to run this. And I'm going to let you guys, and so anyone who has a hack RF, you guys can throw it up and do it. Or I'll walk through it for anyone who's got an SDR, you can see what we're talking about. But I'm going to leave the commands up for you guys. And then that way you guys can actually just walk through it. Because unfortunately, this is one of those where you can transmit out, but without another receiver, you can't watch it. So unless someone is going to sit and record, watching, while it goes, we can't. You can't watch yourself do it. You have to have an SDR on top of something that will transmit. So give me just a second. Is this back in? Let it go. Okay, so the big thing that I want to point out for this exercise in particular is that there are a number of sorry. Come on, paste. Okay, that's what I thought. Okay. There are a number of pictures in your pictures directory. Okay, these are the two commands that you need, and I will get you started on those. Alright, let's see. We've got so if you CD out to your ops directory and go to Spectrum Painter. There are a number of pictures out in your pictures folder. So choose whichever one you want. I like Yoda here in the sunglasses, so I'm going to hone in on that particular picture. But it's Python. Let's see. Okay, so it's anyone who's got an SDR, go ahead and tune into 433.15 megahertz. And you guys will be able to see this as I transfer it out. But so let's go Python, and we'll go Spectrum. Oh, excuse me. Before you do that, go into do a sudo sudo. Just be root for this. It's a lot easier. Python Spectrum Painter image display. Okay. So we're going to set S for the sample rate. If you having a hack RF, the sample rate is going to be 8 million. 2, 3. We're going to do a format. We're going to format this out for the hack RF, and then we're going to choose the file name. So home SDR pictures, and I like Yoda, so I'm going to take Yoda. And then we're going to just pipe that out to a raw file name. I'm going to take it right here and just say yoda.raw. And that is going to take a second. What do you mean there's no path? Dash dash? Is that what I did wrong? Sorry, it's dash dash format. Dash dash format. And that's going to take a second. Okay. Mine's done. RF. So now we're going to do a hack RF transfer to actually transmit something out on the hack RF. And we're going to take the device ID. If you do not remember your device ID, just as I don't remember my device ID right now, you can open up anything like GQRX, and it'll show you what it is, GQRX. So that's your hardware ID. You just need that last 6 digits. Copy. So hack our.
I was just seeing we're still going.
Oh yeah, we've got about another 10 minutes and we're done. Okay, so device ID. We're going to transfer the file name that we created, so Yoda in my case, on the frequency, so -F, so 4. Remember, it's in megahertz, so you gotta pump it out there. 433, 1553. So that's 433.15 megahertz. And then we're going to send the sample rate. Sample rate being 8 million again. 1, 2 many zeros. I can't count. 1, 2, 3, 4, 5, 6. Okay, and the X. The X is actually for decibels. So in this case, 47 is the highest you can go with the RF, with hack RF. There's actually a reason it's like that. One, the amount of power that you can put across the device, but 2, you do not want to be broadcasting all the way out to Asia, because like if we were outside and people were trying to open their cars, we could cause a denial of service against this frequency. So I kind of picked this one last night to try and zoom in on a frequency that I didn't really see in use by anything industrial. All right, so then all you have to do is hit enter. Right now, it's actually it sent it out once, and what you can do is you can just put that in a for loop. Anyone who's got nice bash skills can put that in a for loop, and then just start retransmitting out. Did anybody get that come across? Did that come across in anyone's spectrum? Did Yoda come up? Okay, so I'm going to put it up on the big screen just so it can get recorded here too. But let me open up GQRX and I'll watch one of you guys send your signal. GQRX. Let's see. That's fine. 433. What did I say? 15. Okay. All right. Record. Okay, can somebody go ahead and transmit theirs? See if I can pick it up on the screen. Did that work? It's part of the problem with the low transmit power. You gotta be really close. You gotta be decently close. Here, let me go into my gain. Let's see if I can turn up the gains.
There you go.
I'm not seeing it. But I know when I sent mine out that somebody here in the front, I mean, he's, what are you, 5 feet? 10 feet from me at the most? Yeah. So we could see it when it was sent out, but...
I picked up yours the first time.
Oh, you did?
What do you get now?
Yeah. Well, I'd like to see it anyway. So that really is how you send the pictures through. And we did have it happen in reverse, but obviously, or we didn't have it happen in reverse. But the Spectrum Painter is really well documented, and it's on the ISO, so go have fun with it. It's a lot of fun. So somebody I thought was really creative. Somebody actually sent they sent a QR code in a picture across the spectrum. So they took a picture of the QR code, turned it into a raw signal, transmitted the signal, and then you had to decode it. I thought it was definitely different, you know. It's creativity like that. I just absolutely love it. All right. So the last little slides here, we are coming down right to the end of the wire. Okay, so exploiting RF for fun or profit, or not. You really should check the local laws, the state laws, the federal laws. If you're in another country, they have different laws. The FCC only governs us here in the United States, but it does have there's other agencies and other countries that maintain the same thing. Encoded and encrypted channels. If you crack them, there's no one that can stop you from intercepting the signal and cracking that signal. There's nothing that says that you can't, actually. There's a kind of like gentleman's agreement, let's say, that says you really shouldn't. You cannot report on it. If you publish how to crack in, say like police, voice. Their channels are encrypted. If you figure out how to decrypt those and you actually like tell people, like you will be in some massive trouble. If it's encrypted, don't touch it. If it's law enforcement, don't touch it. If it's emergency services, love God, don't touch it. Don't broadcast without a license. The amateur radio is going on. The class is tomorrow and then testing on Sunday. I highly recommend you guys go through it. It's $15 to take the test, and if you bomb the test, screw it. It was $15 to screw. So if you have an amateur license, you can the technician's license. It gives you access to actually do some stuff and to transmit on some frequencies. Otherwise, you have to stay within the citizen band. That said, you can get away with little things like this. Like we're here, we're doing research, we're in a training class. We're purposely going after a piece of dead air that we can see from our own gear. We made what I would call a proper judgment call, and trying to stay within that side of the legality. Because technically anything you transmit, if you don't have a license, it is technically illegal. So the likelihood of someone coming and knocking down your door because you transmitted a picture of Yoda, not really likely. But if you start squashing signals and you start transmitting out things that are preventing people from getting in their cars and stuff, that's gonna get you arrested. Do not interfere with ADSB or automated information signals. Do not screw with a plane. One, the ethics behind that alone is absolutely ridiculous. If you send that's people's lives you're going to possibly deal with. It is highly illegal, and if you're on a plane, you will be arrested and detained. Don't do it. Antennas in public places. Again, if you're, a security guy comes by and sees you, he's probably just going to take your stuff and then ask questions later. Just be aware. If you have your amateur radio license, though, it's always great that you can pull that out and say, no, I'm doing some research, I'm here, I'm fine here. And you can talk about otherwise just use good judgment. Exceptions. Faraday cages. Okay, so how many people have seen Mr. Robot? And he puts the aluminum foil all over the walls and all that. That's one form of a Faraday cage. It's not actually going to work or do anything against a major signal like that. A real Faraday cage actually is, it collapses around the device or the facility or the unit wherever the testing is being confirmed. These some of the sites, especially for audio equipment and things like that, some of those sites are multi-million-dollar sites to build these things. Yeah, you can build a really cheap Faraday cage. You can even buy like wallets and purses now that act like a Faraday cage. But like you're trying to build one in your house, aluminum foil is not really going to work. There's a theory that says yes, it does work, but I can tell you it honestly doesn't. It's just going to bypass it. If you have contracted work, so I do a lot of IoT stuff. I'm going to go after particularly that frequency that's there. But even though I'm going to go after that frequency for which the contract, for the device that it's supposed to operate on, doesn't mean that I'm allowed to transmit on that frequency. I still have to be careful that I'm not going to interfere with other signals while I'm doing that. So just something to keep in mind. Research, especially when you're going to play with, everyone wants to go play with key fobs and drones and all this other stuff. Just, be aware of the limitations of local laws. If you're not screwing with somebody and causing somebody some bad issues, you're probably fine. I'm not a legal expert. Don't hold me to that. Or Rapid 7. And training, which we just did. Hamming it up. Okay, so amateur radio, I was just going to give a nice little, hey, this is a wonderful thing and everyone should do it. So go a little bit beyond the CB range. The amateur radio or ham licenses, you wouldn't think that, this really seems like an old, antiquated technology just to have a radio. This is something like my grandfather would talk about from the days in the 1920s. I guess my great-grandfather. But, no, it's 3 million people worldwide who do this. And those are just the ones who are licensed. In other third world countries, they may not be licensed. Or that may be how they do a lot of communication, especially like Australia. Australia is huge for shortwave communications and radio. They go across the HF, VHF, and UHF frequencies. The cost of equipment can range from anywhere from $50-$60 to get started to thousands of dollars. There is kind of a middle ground, but the only way that, for someone to really call out what, this is a really good system and explain all the nuts and bolts and why it is a good system, you gotta go watch the YouTube videos of the preppers. And it's just a really bad way to put it, but someone who's a prepper is be like, oh yeah, this is my JVC, da 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 da, and he's gonna tell you exactly everything about it. And it makes it go a lot faster, but they generally find middle ground ones. Also, Power Google is there. Licensing costs about $15, and we're testing those Sunday. Okay, propagation and interference. Gain would be the number one that anyone has any problems with. Otherwise, you get duplicated signals, you get signal bounce, you get bleed, things like that. But when we're actually talking about how we're intercepting other real-world signals, it really does depend on the signal itself. This is why I don't like to play with, I don't like the automatic hardware gain. I like to manually mess with my gain, because then I can go in and play with it on the spectrum, see exactly how it operates, see what the level is coming in, and then I can sit there and record it myself. RF is subject to electromagnetic interference. So if you have, I'm sure that many people have experimented with this or just been, unfortunately, the victim of it. Remember I said a microwave has an FCC ID number? So I went to recently go visit my father in Arizona, and they have concrete blocks type houses. I don't know how to describe the house, but all the walls are like concrete blocks that just been stacked together. We're trying to watch the hockey game, and as we're streaming it in, his TV is wirelessly connected into the network. Well, it turns out that the microwave is right on the other side of the wall. So every time my mother-in-law would go in and start cooking dinner, she'd pop something into the microwave, and we'd lose the signal for the game. Because the frequency was, jamming it, right? So it was subject to the EMI from the microwave. They had been like that for 2 years, and I went over and I was like, oh no, I know exactly what this is. Looked up the FCC ID number on the microwave, found out, it's on the lower end of the spectrum for wireless LANs. It's still in that 2 point whatever gigahertz. So I moved their router to be up on channel 11. Never had a problem with it after that. So I mean, like, there's some fun things to know. Structures, trees, noise. If you can't have a direct line of sight to your signal, it's got to be loud, or you got to have an antenna that has a high gain that can detect through a weak signal. Parabolic dishes are great for doing this. It's just the way that they're built, they actually really focus that energy. Let's see, the higher the frequency, the more likely they are to be interfered and distorted. This is one of the reasons why radar is kind of a piece of crap. There's a phenomenon known as scatter, depending on what's going on. So if you're driving down the road and there's a million cars and it's got all this water being kicked up off the road and it's raining like a son of a bitch, how accurate do you think that radar system is? You got a pretty good shot that it's not accurate anymore, because what happens is that radio wave is so small, it's so precise. When it gets transmitted out, it hits all the water in the air, scatters, and gets reflected back. So you can't tell it's an accurate signal. So supposedly an officer says, well, I've been through training and I can judge how fast a car was going. It's not a scientific method. Not. I wish I had known that when I was 16. I could have gotten a couple of tickets. Anyway, ground wave versus skywaves versus line of sight. If you are trying to go after satellites, you may have to wait until a particular satellite comes across in the horizon so you can actually see it. Atmospheric conditions, snow, sleet, rain, especially the big puffy snow or hail. Hail's a really good one. That can cause a lot of interference. Ionospheric conditions and ducting. Ionospheric conditions have to do with the sun, the radiation from the sun, and how the ionosphere is actually acting. Some signals, when they go up, they actually can bounce off of the ionosphere and come back down back down. So you can actually get great distance doing that. And there's a very particular set of frequency ranges that have better bouncing capabilities, I should call it. But you can get really good distance. Ducting is a really rare phenomenon where cloud layers actually keep hot and cold like conduit. So as the signal enters into this layer, it literally bounces across the layers, and you can pick up signals from half the world away. How noisy is it in your area? If you're in like a downtown super noisy area, you've got signals that can bounce off of buildings. You've got all the street noise. You've got all the ambient noise. You may not be able to get the antenna high enough, so your environment can have a real big impact as well. I'm going to skip over line of sight. You can beat that one. Shifting polarity. So I know this is physics, and physics means that it's a science, and science is a very solid operation path. It's bullshit. This is a lot of guesswork too, especially on our end. And things happen. So just because it's transmitted out as a 1 and 0 doesn't mean that it actually gets interpreted as a 1 and 0 when it gets intercepted on your gear. So it can actually shift bits and do it wrong. Remember when I recorded the FSK and I tried to show the 1s and 0s, I had 0, 0, 1, 1, 0, 0, 1, 1 instead of 0, 1, 0, 1, 0, 1. I had doubling up because the gain was so high. It's just how it transmitted out. It's not the way it got intercepted. So the only way to get around that is to take multiple samples of the same signal, and make sure that you have clear conditions. Multipath interference. Especially if you're in an area where there's a lot of buildings, if you're trying to do point-to-point communications and intercept something where you like with a Yagi antenna, just because you're pointed at it doesn't necessarily mean that that signal can't be bouncing off somewhere else. So just look at it in the spectrum and make sure that you're not seeing duplicate or like a duplicate image, where it's kind of slightly off or shifting a bit. And then there's skip zone and skip distance. Remember earlier I said you can't intercept a signal by pointing the tip of this thing? Well, most towers, they're so high up, they actually have a bit of distance underneath them, where if you're standing underneath them, you're not going to get any signal. But if you just continually back up a little bit, or in the case of, you know, an 80-foot tower, it may be like 40 feet you got to back up or so, you know, but eventually you'll get a much better signal because there's a cone of silence, basically. It's a horrible area for a signal. And skip distance, when you have long-range waves, especially when they go across large areas of open plain area or water, they can actually skip, bounce in the air, come down, and you can end up with dead zones and dead patches and stuff like that as well. So, that's the interference. All right, did I rush through that fast enough for everybody? Questions? Concerns? That's 4 hours of listening to me drone on. I appreciate every one of you guys for not falling asleep. But I hope you guys have go and have a good time, good fun with RF. It's one of those projects where when you start it, it becomes this. Like, oh, okay, this is cool. Okay, all right, now this is really cool. Holy shit, this is amazing, and you will not believe how much stuff is in your house that transmits radio signals, and how much stuff you can screw with. And we are in a really great time because a lot of IoT stuff, a lot of just consumer grade electronics, they are ripe for the plucking. They're ripe to play with, and it is fun, so much fun. So I hope you guys learned something out of this. I'm sorry we had so many problems with all the demos, but that's the case of a live class, unfortunately. So maybe better luck next time when I revamp this class. So thank you very much for coming on out.
You did really good.
Oh, thank you. I appreciate that. My moral support. I love you guys.
If you don't mind, sir, thank you. Appreciate it.
Hey, I only got one of the USB drives back. If they don't come back, I don't care. Have one? Okay, cool. All right, well, it makes the company happy, I guess. Beautiful. Okay.
So I take it you're licensed.
You'll get dinner.
I take it you're a licensed ham. Taking test tomorrow
Yeah, take class on Sunday.
or Sunday.
Yeah, I've been meaning to for a while now, and I've gone through the training a few times, and it's just something always comes up, and I haven't been able to get my license. So.
And I think we worked it out so that it's free on Sunday.
Oh, is it free on Sunday? Oh, nice.
Part of the registration.
Hey, you know what?
Well,
After a
hey,
long day, I know it's not like this stuff that you're really interested in.
So you stop it first, right? How do you stop it?
Yeah, no, but it's not. That's yours.